Sir, can we start?
Yeah, please, ma'am. Yep.
Kishore, sir?
Yeah, sure. Please kindly go ahead.
Yeah. Yes, Shruti, you can begin.
Yes, ma'am. Good morning, everyone. Hope I am audible.
Yeah, you're audible.
Knowledge has a beginning, but no end. I, Shruti, Assistant Professor, Department of Electronics and Telecommunication Engineering, Bangalore Institute of Technology, welcome one and all for 3-day workshop on design and simulation of wireless communication systems, conducted by Electronics and Telecommunication Engineering, BIT, under the auspices of Rajya Okkaligara Sangha in association with Arts and Keysight Technologies. The motive behind this workshop is to introduce key concepts and recent advances in digital wireless communication systems. Dignitaries for today's inaugural function are Flight Lieutenant Shri Annam Tyagaraja Kishore, CEO, Vidhya Sangha Technologies Private Limited. Mrs. Gayetri, Application Engineer from Arts. Mr. Muthukumar, Application Engineer, Arts. Mr. Srinivas, Application Engineer from Arts. Dr. S. Shantala, HOD of Electronics and Telecommunication Engineering and HOD of various other departments. We begin the inaugural function seeking the blessings of Lord Almighty through an invocation song by Miss Niharika. I call upon Miss Niharika to give the invocation. Niharika.
ॐ गणप अम्बासुत कुम्भपुरुष हेमाङ्गहस्तिमुख हे पुण्यचरिता ॐ गणप अम्बासुत कुम्भपुरुष शङ्करन प्रियसुतने ओङ्कारमूर्ति सङ्कर्षणाज भवदेवाग्रपूजितने ब्रह्मवटुरूपि शिवनात्मलिङ्गव पुरदे ब्रह्मवटुरूपि शिवनात्मलिङ्गव पुरदे ब्रह्माण्ड देहि ब्रह्मित तेजरूप ॐ गणप अम्बासुत कुम्भपुरुष हेमाङ्गहस्तिमुख हे पुण्यचरिता ॐ गणप अम्बासुत कुम्भपुरुष ಪುರಸಿದ್ಧಿದಾಯಕನೆ ವಿಘ್ನಗಳ ಕಳೆ ಕಳೆದು ಪೊರೆಯು ವಿಶ್ವಂಭರನೆ ಗಜಮುಖನೆ ಗಣಪತಿಯೇ ವಕ್ರತುಂಡನೆ ಶಕ್ರದೇವಾದಿವಂದಿತನೇ ವಕ್ರತುಂಡನೆ ಶಕ್ರದೇವಾದಿವಂದಿತನೆ ವಿಕ್ರಮನೆ ಕರೆ ಮುಖನೆ ಕರವ ಮುಗಿವೆನು ಪಾಹಿ ॐ गणप अम्बासुत कुम्भपुरुष हेमाङ्गहस्तिमुख हे पुण्यचरिता ॐ गणप अम्बासुत कुम्भपुरुष Thank you.
Thank you, Niharika. Now I call upon Dr. S. Shantala to give welcome speech.
Thank you, Shruti. Good morning, all of you. It is a privilege to deliver this welcome address. Respected dignitaries, heads of various departments, my colleagues, participants, and everyone present here. I'm indeed glad that the Department of ETE, Bangalore Institute of Technology, has organized this faculty development program, which is a 3-day workshop on design and simulation of wireless communication systems in association with Applied RealTech Systems, ARTS, which focuses on system theory and practice in the digital wireless communication domain through industry standard tools. This FDP is a small step in trying to identify gaps and going beyond the syllabus content in order to bridge the gap between the academia and the industry. It is my great today's keynote speaker, Vice Lieutenant Annam Tyagaraja Kishore, CEO, Vidhya Sangha Technologies Private Limited, and also a senior IEEE member, for honoring our invitation. On behalf of principal and staff of DIT, and on my personal behalf, I welcome you, sir. Welcome, sir.
Thank you, madam.
Thank you.
I would like to extend a very warm and cordial welcome to Mrs. Gayetri.V.Ranjeri, Application Engineer from Arts, and Muthukumar J, Application Engineer from Arts, and Mr. Srinivas, Marketing Engineer from Arts, who are our organizing partner. Welcome you all here, madam.
Thank you, ma'am. Thank you, madam.
Thank you,
Thank
sir.
you.
Thank you, sir. A warm welcome to our beloved principal, Dr. Ashwath MU, who always encourages us in organizing such events. Okay. I extend a warm welcome to all the participants who have registered for the workshop. The response was overwhelming. Thank you for the overwhelming response, participants. I would like to welcome all the heads of departments who are present here, my fellow colleagues from various departments, for having honored our invitation and for having taken time off to attend this event. Last but not the least, I welcome the staff, both teaching and non-teaching, of ETE department, who have been working very hard to organize this event. I take this opportunity to request all delegates to stay motivated throughout the sessions and extract maximum out of this workshop, which involves hands-on sessions too. Once again, I welcome one and all present here. Stay safe. Thank you.
Thank you, madam. Now I call upon my colleague, Professor Jamuna, to introduce our chief guest and keynote speaker.
A very good morning to all. So on behalf of Department of Electronics and Telecommunication Engineering, BIT, it's my great pleasure to introduce today's keynote speaker, Flight Lieutenant Shri Annam Tyagaraja Kishore, CEO, Vidhya Sangha Technologies Private Limited. Mr. Kishore is highly accomplished professional with 33 years of fruitful experience in manufacturing technologies, including business reviews. Mr. Kishore domain specializations include IoT, 5G, UAV, Open IMS, Open EPC, virtualization, cloud computing, and many more. He has acquired international exposure through working in USA, France, UK, Singapore, Hong Kong, Spain, Abu Dhabi, Sri Lanka, Australia, and New Zealand. Mr. Kishore is well adversed in providing system integration, global service centers, pre-sales and post-sales support on 3GPP, OMA, IPTV, and many more. He had rich experience in advanced research in optics, IP, wireless, wireline, business process, governance, and budget management. Mr. Kishore is an accomplished functional expert specialized in EPC, IP core for mobile, broadband MPLS, service routers, and proficient in requirements definition, future process design, gap analysis, interfaces, and testing. Mr. Kishore has also contributed for many publications, books, reports, chapters, general articles. Mr. Kishore is a jury member for Drone Designathon, and at present, he is the CEO of Vidhya Sangha Technologies Private Limited. So with this brief introduction, I heartily welcome Mr. Kishore, sir, and request to deliver the keynote address. Over to you, sir.
Thank you very much. Let me just start by sharing the screen, and in the meanwhile, I would like to take this opportunity to appreciate the efforts done by our college, especially focus on test and measurement, and which is one of the key areas that you need to be looking at for great depth in the areas of that. Okay. Hope my screen is visible now.
Yes, sir, it is visible.
I will bring the presentation up just a minute. Okay, is my first screen visible now?
Yes, sir, it is visible, sir.
Okay, sure. So in sync with the theme that you have chosen and the topic that you would be dwelling upon for next 3 days, including today, I'm also very happy to know that arts is associated with you. They are pioneers in test and measurement evangelism, and I've seen some of their work in the context of Keysight and other defense related testing environments. So the design and simulation of wireless communication systems 2021. And broadly, when you talk about wireless networks, the current world is on the elbows and knees of the wireless industry now. Though it is ubiquitous, you may not be aware. So the internet access or the digitalization and the transformation, the world has completely transformed during the last 40 years from first generation till today. And typically every 10 years there is a, quote unquote a new revolution or a wireless standard that is emerging. So the 5G is already in place for the last 10 years. So it's a time for actually 6G, and it's a very good time to review techniques of how to assess the design of 5G so that you would also appreciate how it relates to evolutions of the terrestrial and non-terrestrial evolutions, which brings the context of 6G as well. So while preparing for your talk, I really felt so happy that in the industry of wireless, three companies since the beginning, like Motorola, which is now acquired by Qualcomm, and Lucent Technologies, which is now part of Nokia, and it's a transition through Alcatel Lucent, and Qualcomm. These three companies played a vital role in certain technologies like CDMA, and that extended to WCDMA and 4G and 5G, and further to the 6G and 7G. So I would like to start with the journey of wireless last 40 years. While it is small in form factor, let it be like that. I gave you the links, and you could actually try it out in mute in your respective machines. And the idea is to create an awareness of what happened to the wireless last 40 years. So by 2013, when this has been uploaded by them, the world had around 6.3 billion wireless connections. Right now, you may have around 10 billion wireless systems in place for our multiple requirements. Some of you may have more than one wireless connection. And Qualcomm is one of the pioneers that has led the story of wireless in US at least, and then taken very graciously through rest of the world, as you could see in the 40-year journey of wireless. Ever since Qualcomm stepped in for CDMA, most of the story is how Qualcomm led the research. So like for Intel for laptops or IBM for machines, Qualcomm became the chipset provider and became enabler for all kinds of mobile devices and networks, be it WCDMA or revolutions within CDMA, known as EVDO and CDMA 2000. There are other experts from Qualcomm explaining the efficacy of 5G in their labs in America. I don't want to disturb the form factor, and just to give a glimpse of them both quickly. There will be noise, but you will see the animations, and then these are the links, and you can go through. These talks in themselves will consume an hour. Idea is to create an awareness and to move forward from there.
Hi, I'm Sam Kotla, Senior Staff Engineer.
So that is called noise. Let that noise be there. I will explain sometime later.
In Industry 4.0, as industry leaders seek to improve operational efficiency and responsiveness. 5G is a foundational Industry 4.0 technology.
Okay, so you have seen three people talking simultaneously. And in fact, the challenge of wireless is how do you ensure out of the three, only one is what you are interested in. So that is what is called noise cancellation. And the way that CDMA started to do was to make use of some code division multiple access using some Walsh codes and the principle of the cross correlation and anti-correlation. So if the two codes that you are comparing, the one in the memory and the one that is arrived by your rake receiving, if they both match, then there is a maximum correlation and that would be presented to you as voice. And if the codes don't match, it would cancel them. Therefore, as you could hear, I enabled all the voice at the same time, which would become a cacophony. But using CDMA technology, you would only be listening to one code at a time. That is the code that you have been allowed to utilize for your conversations. So in fact, the 5G that you use today, or at least in India, it is in experimental stage in a number of IITs and IISc Bangalore, and the rest of the world it already started, like in the US and America. It has all the merits of the code division multiple access that Qualcomm has brought into the fold. So the 21st century networks are becoming increasingly more intelligent, and that's even before the artificial intelligence gets to look into the scene. So the wireless that you would be interested to learn is already enabler for the artificial intelligence and machine learning, and the developments taking place in the computer industry and the other areas such as intelligence and IoT are also contributing to the applications and the wider reach of 5G and the other revolutions that are emerging. So there is a nice document, a future of 5G, and there is also a 1 hour of talk around it by the team. And so I encourage you to, one of the best ways to learn physics is to listen to Finman. So the very noble way to learn wireless technologies is to not to look at Qualcomm as a company, but something like Bell Laboratories or physics. Nobel laureates existed in that company. So Qualcomm, I don't know whether Andrew Witterby received an award of similar nature like that of Nobel, but certainly that has contributed a great deal to the world of wireless technology. So I was so fond of Qualcomm as a professional learning. I wrote white papers published in CDMA development group, and Qualcomm and the leaders of them responded very quickly to what I have written. So basically, this is adopted from Andrea Goldsmith for US students, and the idea is to get you the knowledge that this is the typical diagram used in various wireless courses. In fact, there used to be a few RF professionals in US like Scott Baxter, who popularized the knowledge of wireless. And these are the diagrams that originally came from Scott Baxter kind of knowledge series on RF for CDMA. So you see here the number of towers. This is a tower like a cylinder, and there is buildings, a multi-path environment, and you have these vehicles, the cars, which are the consumers of the wireless. Here is a case of how wireless helps in case of your connected car scenario, where the car and another car is connected, and also car and the roadside unit, which is the tower itself, and how the roadside unit is connected to other greater ambience, and then the intelligence coming from the pedestrian information system or the camera feed, and some of the violations of, let us say, a pedestrian walking when there is a red light for him or her, and how does that translate to the vehicle behavior and one vehicle behavior to other vehicles in the link, so that they don't collide with each other when one vehicle applies sudden brake or takes precautions to prevent accident with that pedestrian misbehavior. So this is an interesting subject, and a lot of research is still ongoing, even much beyond the scope of wireless, to solve the challenges of the connected cars and autonomous vehicles. As you would be taken into the depth of error vector magnitude and some of the tools that you may use from likes of Qualcomm MATLAB, this is the some of the fundamental concepts of wireless. ISI stands for inter symbol interference. CDMA has a number of overlapping symbols, and the only way you can make sense out of the noise on top of intelligence is more than 18 dB, which actually means that there is a mountain of noise on intelligence. But when you apply correlations and proper mathematics to arrive at your signal and reject the noise, all of a sudden something like a something like a volcanic eruption, the truth emerges from the mountain of ignorance, and as invocation to the Lord Ganesha that you started with. So you get clear about all the darkness around, and you pursue your truth. So that is how the is the intersymbol interferences and noises can be cancelled by applying the proper codes, and all the noise can be removed by this color coding things like the red color, and finally you have that Gaussian kind of alpha SF. So that is how you get your required information, and in the backdrop of all the noise that is there, noise cancellation characteristics. So the rake receiving is one of the fundamental assets that has led to the success of CDMA technology. It gave actually 20 dB advantage compared to other GSM and other wireless technologies, relatively in the mutual channel path between the transmitter and receiver, and in the reverse path for the collection of the data that you are looking for and rejecting what you are not looking at. So as I said, CDMA is based on Walsh codes and cross correlations, and every rake finger is focused on a certain signal of a certain time slot and angle of arrival, and you want to focus on collecting instances of the reinforcement that you are getting the same type of data in that particular receiver section. And you try to look at all the receivers which are working in parallel, and see which of those receivers are giving you better results, just like investing in stock market, and you will do the maximal ratio combining, and then you will take the final result, which would generate the positive result that you desire. So this technique of parallelly dividing the task and looking at the signal arriving at different instances of time and applying codes and verifying, and that rigorous mathematical job happened due to a very interesting story in US. So way back before all the wireless, including zero generation wireless, that was like advanced mobile phone system, which we could also call first generation, let us say, for our conversation. There was a phone which was in a car, and to give a feel of a rotating black phone with a cable, they kept a phone like that, and that used to be the kind of a zero generation phone. And so from there till now, what happened is that America started off with Ameritech, some experiment of Bell Labs to test CDMA 1.23 megahertz spectrum, and the ability for them to test that, the background information was that there was one Hollywood actress from Czechoslovakia who settled in US, Hedy Lamar, and her son runs a charity for the intellectual woman in engineering, what we call in IEEE, to support people who take up STEM technologies. So she contributed immensely for all the technologies that emerged, including WLAN, Bluetooth, and other related technologies, including OFDM that is used in LTE and that has evolved into new generation radio for 5G. So to design, because your colleagues from arts will take you through these details of the design challenges, the typical points that as this is the keynote talk would center around these attributes, like how do you model a channel, just like Shannon's modeling theorem, capacity theorem, and also how do you do the traffic patterns. So CDMA relative to GSM gives around 6 to 10 times better capacity than GSM, because in GSM we have a constraint of time slots and frequency planning and reuse. In case of CDMA, there is a universal frequency reuse, and the number of channels you can enjoy is only limited by mathematical limitation of the number of Walsh codes that you can generate. Of course, the noise need to be optimized. So it relative to GSM, CDMA started to give, at least in the beginning, 6 times better performance than GSM. And also, given the fact there is a universal frequency reuse that has acted like a force multiplier and gave more and more return on investment to the telecommunication service providers, like in India, Reliance and Tata's, and elsewhere in US, the Verizon Wireless and China Telecommunications. So in designing a telecom system, you need to know what are the number of end user voice channel carrying channels that you have, how many of them are dedicated to the one individual, what are the quality of service parameters, and how about the power levels, what is the spectrum. All these areas is mentioned here in the bullet points. Energy, then delay, that means that when you transmit, before it is received by the end user, what is the latency. These are some of the parameters you consider in designing. So here is some tower, there is a multipath, and finally it is reaching that car. So multipath propagation. And similarly, due to the propagation, there is a power that is transmitted. When it reaches the destination, it undergoes macroscopic, microscopic variations and Rayleigh fading, and eventually the signal will undergo degradation. So there is a distance square law proportional to the distance that you move away from the transmitted. The received power will be proportional to inverse square law. But if the receiver is tangential not in line with the line of sight, then it could be proportional to not only square of the distance, but the value 2, that is 1 by proportional to 1 by r square. That 2 can also be 3.4 due to the factor of the orthogonality. So when that is the challenge, how does this wireless technology, how do they solve these issues? They solve by taking advantage of multipath propagation and comparing which of those multipath is in your favor, and use this very rigorous mathematically functionalities like Bessel's function, like sin x by x integral 0 to 1, and Gaussian, and a lot of such processes, which I think the Keysight and arts team would take you further into error vector magnitude, etc. So here there are certain modulation considerations. One of the important things that is adopted in LTE, a predecessor to 5G, is there is a QPSK modulation that is afterwards, when the conditions are good, you can have 16 QAM or 64 QAM. So that multiple ways of doing quadrature amplitude modulation is written as M QAM, and that 64 QAM can also be 128 QAM or 256 QAM 512 as the 5G evolved. So these are the examples of the 8 PSK, 8 phase shift keying, and so the data that is conveyed here is 2 to the power of 3 is 8. So using 3 bits, you will generate 8 states. And these are some maths, and I would like to highlight there is also something called Doppler effect. It means that if the transmitter is fixed at one place, like a tower, you won't see the Doppler effect. But if it is a train that is moving in a rail, and you are static in a platform and observing the incoming train, you would see the Doppler effect of sound emitted by the train in the previous location, and also in their current location. There is an effect of overlap between them and beat frequencies, and so the Doppler can also be measured to give you an indication of the movement of the object, something that astronomers have also used to understand the star movements. The same thing can also applies to wireless technologies. Intersymbol interference, as I mentioned earlier, and capacity fading. So to understand fading channel, in fact, that is what Indian spiritual masters tell us, that the world around you is full of noise, mithya. So that's what technocrats also tell you, that the world around you is full of additive white Gaussian noise, and you need to get your signal to noise ratio resolved by meditation, dhyanam, and then you have to be sthita prajna. So typically that is how wireless industry as well gets down to the business of focusing on what you need. So this is how the 16 QAM is very well articulated in this 4 quadrants, and you got 4 dots there. If you add all of them, it is 16. 2 raised to the power of 16, 2 raised to the power of 4 is 16. So by using 4 bits, you can take a paper and pen and start with 4 zeros, and finally conclude with 4 ones. You will generate 16 variations of them, and that is that they are symbolically mentioned in these various colors here. And so this is the 64. Then when you talk about 64 QAM, keep all these 16 in one quadrant and populate the other 3 quadrants, then that becomes a 64 QAM. So basically, how do you go about in the wireless channel modeling? You have to look at the phase constellations, and what are the power, and what is the error in estimation, what is the delay. These are the parameters that the test equipment will take care to get you the signals that you are looking at in your practical lab. So we have to use the techniques of selection combining, maximal ratio combining, and equal gain combining. So maximal ratio combining is like what Warren Buffett or others who are well versed in a stock market, the algorithms of maximal ratio combining, they go by which of the stocks you invested in the market are giving better results. You increase your portfolio and you arrive at the profits. This is the concept used in the wireless processing. So you have the explanation about how does the MRC work, maximal ratio combining, and also selection combining. So maximal ratio combining gives you like 40 dB gain against the relay fading, which actually is the story I told you. Like there is a mountain of ignorance and a heap of darkness, just like a Java explosion. There was, I think, before our current civilization, there was one mountain in the Indonesia that exploded, and now the whole world went into cold era. So, and then that gets that 40 dB gain you will get by maximal ratio combining. That gives you like a volcanic eruption and penetrate through the darkness, and you get your signal enlightenment to you. So the selection combining, typically MRC gives you 40 dB, but you don't think that every time stock market behaves the way you want. Therefore, that gets rationalized to a selection combining technique of 20 dB gain. So between 40 dB of MRC and selection combining 20 dB, you get a average effect of them in the reality picture. And you should be happy if you get 21 dB gain over the noisy channels. So MIMO is something that again Indians should be very happy about listening about the stories of MIMO, because there was a Indian Navy officer who went to Stanford, Professor Arugyaswamy Paulrajan, and he went for a haircut and multiple strands of hair falling off his shoulder, and the haircut professional was in a soft conversation with him, but his mind was elsewhere, like eureka moment. And after the haircut, he has published that multiple input multiple output philosophy, and his professor under whom he was doing the PhD was so happy, and so he received a Marconi award for communication, and also government of India has given him the chair position for advisory committee, steering committee to the government of India to guide in the strategy and guidance on how India should go about in the deploying the 5G technologies. That is the story of MIMO. When it comes to LTE, MIMO was at the realm of about you have a 4x4 MIMO typically, and then they had about a concept of 8x8 MIMO, but none of the commercially available industrial deployments or the mobiles that we normally purchase, they are typically 4x4 MIMO maximum, and mobiles used to transmit 2x2 MIMO but receive 4x4 MIMO from the base stations. This used to be the standard concept of 4G smartphones. But as the 5G evolved, so you have got a 64 by 64 MIMO systems, which the Qualcomm speakers there, other two speeches that I initiated, they explain you how the 64 by 64 MIMO was effectively made use of in their industrial applications. So MIMO is something that Indians should be feel happy about for the world of communication systems. So there are some more equations. I would like to talk about a few concepts. So one is called OFDM, orthogonal frequency division multiplexing, and FFT, that is a fast Fourier transform. Any discussion about wireless or signal processing without knowing the life of this gentleman Fourier, this is a boy whose teacher ignored his potential merits as a student. So he called upon his parents and told him that your son is no good because he can hardly see anything. He is no good for studies. You take him away. But now later on, this boy who is having imperfect vision has opened our eyes to the possibility of lot of mathematical rigorous um, applications, and without which most of the advanced technologies could not exist now in DSP. So fast Fourier transform is thanks to Fourier, John Fourier. Similarly, OFDM, all of you take a, especially the researchers and students, take a paper and I'll tell you the formula for the LTE, the OFDM philosophy in 3 components. So first component is 14,000, 14000, multiply symbol and then 1200, again multiply and 6. So these are the 3 components. When you multiply, it gives you 100 Mbps. So 14,000 is the number of symbols you get. That is where Qualcomm, like chipset manufacturers, generate the chips which are capable of emitting 14 symbols per millisecond. And 1200 is the number of sub-carriers. Yes, is there something? Shall I carry on?
You can go ahead, sir.
Okay, fine. Good. So the fast Fourier transform deals with modulation and demodulation. So in fact, the selection of the LTE before its birth, there was a competitor known as WiMAX. And to select whether WiMAX would sustain or not, the discrete Fourier transform was one single tool that helped LTE become triumphant in the uplink by using a technique known as peak to average power ratio, and to help the mobile devices to consume consume less of power to deal with random variation of the input signals, which necessitated the power electronics of mobile to discharge from the peak to the valley, and then that has dissipated the mobiles without using the discrete Fourier transform technology, which again is thanks to that bad student who turned out to be the savior for mankind in technologies. So the fading channels, you would go through more details. Dr. Gayatri will go through. So I just want to create an awareness that all these things exist. And so I have a few more videos as well. First, we will go through some and then see how much time we have to further go into other discussion. So in telecom, Aloha is a very interesting concept. It means when randomly many people try to access a channel, especially in the access attempt, random access channel. So Aloha algorithm would create a randomness so that no two mobiles access attempts are colliding. So their attempts will be randomized so that there is a very little collision taking place. And this is a very interesting diagram of cellular technology. The GSM has given birth to that hexagonal design patterns. And when it comes to 5G or LTE, every hexagonal pattern will use the same frequency like any other hexagonal system. And the way you distinguish between one user to another is by using some codes which will identify the base station and the device and the channel. All the three. There are three codes. One is identifying the tower, another is identifying the device, another is identifying the connection between the device and the tower. So these three codes will help you to mitigate the fact that all around the same signals are used by all the other towers. That is the concept. And in case of GSM, there was the requirement of frequency planning, and then the 5G or LTE did not, or WCDMA, there was no need to do frequency planning. These are some of the design considerations, because these 3 day talks are all about design considerations. So you have to know, if let us say you are designing a fresh 6G network for Bangalore city. 5G is already taken care by telcos. 6G something is a research topic, for example. So how do you go about designing 6G? You have to know what is the reuse distance, what is the size of a cell, and what are the ways that you will get interference, and what are the kind of antennas you have, what kind of power levels in the including the antenna gain, and there are any multi-user detection technologies, and how are the resources allocated. These things, if you know, you can even model the 6G technology. By the way, 6G is a combination of terrestrial and non-terrestrial, which is typically used in satellite communication. So resources in terms of wireless include channels, the bandwidth. For example, you talk about GSM. GSM is based on 200 kilohertz channel bandwidth baseband. CDMA is based on 1.23 megahertz channel bandwidth of baseband. And 3G is based on 5 megahertz or 3.84 megahertz of the baseband channel, and LTE is based on 20 megahertz baseband channel. 5G can have various spectrum baseband allocations even beyond 20 megahertz, which is standard for LTE. And power, rate, and base stations and access. These are the resources to plug into the tools, test and measurement devices to design the characteristics of your uplink and downlink. So from the tower to the mobile is downlink and mobile to tower is uplink. And the aim of all these research in the labs is to minimize the blocking and maximize the number of users and maximize the revenue generated by the company which is investing in this technology. So most of the researchers in academic institutions, they do a lot of wireless sensor networks and cognitive radios and ad hoc networks, and they work in this manner that there is many to many communications, and you characterize based on quality of service and optimal routing technologies. And there will be, you deal with about hundreds of nodes, and you also want to know the open shortest path first, or how do I reach to a destination by consuming less of my energies. That is what is the consideration in the energy efficient algorithms. So quality of service is a very interesting parameter. I asked you to simulate numbers pattern from 0000 up to 4 times ones, which will generate 16 variants. Now again take a white A4 sheet paper, start at the top corner. You start with 6 zeros, and ultimately you have to arrive at 6 ones, and don't stop in between. And then it means that you have built 2 to the power of 6, 64. That means 6 zeros, that is 0. Then 6 ones is 63. So quality of service is based on a 6-bit number pattern, which is called differentiated services code point as per IEEE standard 802.1, and that is adopted in wireless for giving you the various special privileged access to some corporate customers, just like Bill Gates or Warren Buffett, who can afford more bill payment compared to normal users. So in wireless, you have to look at how do I take care of quality of service while also serving the normal users. So these things you would come to know from your discussions with your Dr. Gayetri's team. So you need to know the design of applications, network access link, and hardware. So basically there are 7-layer OSI, and that has been engineered to talk about these 5 different layers. Application layer, which is the 7th layer of OSI, network layer, which is the 3rd layer of ASI, and then access and link are the 2nd layer of OSI. Hardware is the physical layer of OSI. Now the 5G will, as it is a thumb rule, every 10 years you have got technology changing to new one. So 5G already spent 10 years, even though we haven't rolled out in India, and nearly 10 years. The paperwork started 10 years ago, and practicals started to show up from release 15 discussions. 13 and 14 were kind of a warm-up phase of going into 4.5G, and that is how everything has now come to nearly 10 years of journey of 5G, even without letting the 5G airwaves in India. So once 5G sets in, there will be a tenure of 10 years for 5G from now, let us say 2022 to 2032, by then the 6G would have become perfect, and we would also roll out 6G during 2030, and 7G would be from 2050 actually, and that would actually be a combination of all the IoT devices and the wireless devices and robots, and then really you will see a artificial intelligent world around you with the 7G in place. That will be another 30 years from now. So these are some of the concepts. Some of them I mentioned about sensors and information theory. So using wireless, what do? We communicate information. So we convey bits like kilobits per second, megabits per second, and gigabits per second, terabits per second. So information is conveyed in the channels. So you have to know what is the capacity, and you have to model it. That is what your arts team will help you to model those things. So in fact, next 20 years, 7G would come, and so actually the 7G, 6G are already realities now, and 6G would be wherever the wireless industry has left out some gaps, just like for example in the language of United Nations Sustainable Developmental Goal. In fact, the United Nations and ITU also have embarked upon 6G to be a technology which will fill up all the gaps that have taken place till now in deploying wireless, and that will be the role performed by 6G. It is not that it is greater than 5G. It is something like a feedback and a stabilizing technology after 5G to make the world more stubborn in terms of wireless. So it will give you like gigabits data rates. Definitely 5G itself gives you 10 Gbps, and it will give you more than 11 Gbps practical figures. And in India, we have an alternative to the wireless, which is through fiber optics. Prime Minister, our Honorable Prime Minister Sri Narendra Modi mentioned about it August 15th talk of 2020, and we have another August on the pipeline now. So 365 days happened almost. So 1,000 days from the time when he spoke, everywhere, every village in India will get 100 Mbps data rate. So 6.5 lakh villages India, there is a 100 Mbps digital data pipe. The wireless technology implementations can also work with the fiber optics, as you would see that most of the 5G is based on fiber optic connections between the towers, and therefore even the government of India GPON technology to BharatNet, it would be a enabler, and the fiber optics reaching the villages will help in the rollout of 5G and 6G for India going forward in coming 2-3 years. Internet of Everything is also relating to this. And there is India having its own satellite network known as Indian Constellation for navigation, and world at large, America, they launched 24 satellites they call Global Positioning System, which is used by our Uber, Ola, or Voyo, etc. Every day we depend on that. But India has its own satellite constellation with which the networks refer to it for latitude, longitude, altitude, and timing reference. And this is the comparison of 7-layer OSI and how the messages flow from one user to the other user, and same concepts work in the telecommunication stack as well. And as I said, the 7 layers have been simplified into 5 layers. So application, presentation, and session is combined as application, and the network is mentioned, but transport is not highlighted in the previous bullet point. Transport includes a streaming control transmission protocol, which is very important protocol used in wireless, much ignored in the IT paradigm like networking textbooks, but wireless uses a streaming control transmission protocol that is sitting alongside TCP and UDP of the transport layer. Every channel will have a data that gets encrypted and transmitted, and there is propagation, and receiver will remove the noise, and then you decrypt the data and you get the intelligence back. So this is the typical the flow of any communication channel. And I would now spend a few more minutes on the 5G as it is being introduced. Worldwide, there were unintended consequences of the movies like a Robo 2 or something, even in the Western world. It is okay that villagers may get influenced by the movie like a Robo 2, and then they think birds are killed by 5G and they want to destroy the wireless towers. But in the movie also, that hero destroys one wireless tower and he feels triumphant. There are millions of towers and billions of users. So that story is not scientifically valid, and the wireless is not causing any harm to the birds as you perceive. Birds may be at danger due to various reasons. Radio communication could be one of the sources, but not just 5G. And so now, since there is no escaping from the rolling out of 5G, we also need to recognize the fact there is a threat of security. So to make 5G more secure, you need to make this kind of a flow chart. So you have to know what are the models of barrier to security and what is the ciphering mechanisms. And you have techniques like IP security. There is a three-letter word used in the security paradigm, which you use like a secure token known as a ravished, Shamir, and Adelman, three people, based on which there is an RSA algorithm, which is also very useful in implementing 5G security. And while analyzing security, you also bring in the context of how quality of service will implement security, because only the highly secure channel you give high priority. The suspicious channel you quarantine and downgrade its priority levels, even though initially it is perceived to be of high channel quality of service. It may be an attack. So when there is certain evidence that this channel is not good, then you quarantine and then help other channels sustain. That is the method of adopting quality of service for security implementation. And there are details here. How do you check any system vulnerability assessment or vulnerability testing is by ping test or a trace route or some of the distributed denial of service floods, sync flooding. There are tools developed to mitigate these various attacks. So a future building will have so many of these devices deployed, which will perform their discrete job, which are what our personal digital assistants like our we have at our homes. We have Alexas and also Google Home and Apple Siri, etc. And so they are also combined with the capabilities of the wireless technologies. So in fact, every channel, this is something like a physics of wireless. ET, that is the T is the time, random variable. E is the energy, is a constant A, that is amplitude at a time T, cos of omega T plus phi T. This is the something like the Newton's first law or F is equal to ma equation for wireless technologies. Starting from here, you will now roll out amplitude shift keying, frequency shift keying, and phase shift keying and QPSK. All these technologies are by manipulating the amplitude A or the frequency omega or the phase phi, and that is how you get ASK, FSK, and PSK modulation standards. And this is the global frequencies electromagnetic spectrum starting from 0 hertz to infinity. Industrial, scientific, and medical bands, they have been opened up for free. Like our WLAN is based on 5.3 gigahertz, and 2.4 to 2.5 gigahertz is allowed as a free band without license fees. And so all these frequencies are used in various applications. And 433 megahertz typically is used in the drones, and 915 is used in the GSM, and 2400 megahertz is used in WCDMA and also WLAN. And these are the differences of frequency division, multiple access, time division, multiple access, and code division, multiple access. And afterwards, we developed orthogonal frequency division, multiple access. As I told you, 14,000, that is one of the paradigms of OFDM. And the tiny sinusoidal waves which are orthogonal to one another, and you bring out 1200 of those waves in 20 megahertz. So out of 20 megahertz, take 1 megahertz to the left and 1 megahertz to the right. You are left with 18 megahertz. Divide 18 megahertz with 1200, you get 15 kilohertz. That is a sinusoidal wave known as a subcarrier. So beyond FDMA, TDMA, CDMA, we have OFDM, which is used in LTE, and 5G new radio uses a flavor of that with variations in the slot duration and also sub carrier frequency baseband allocations. So there are certain basics of generating any wave: return to zero, non-return to zero, bipolar, Manchester. These are all the signaling standards, very much basics of digital electronics. And this is the Gaussian curve. And as I mentioned, the lady Hedy Lamarr was wife of a Czechoslovakian army officer, and she was a host for her husband's guests come as a living-in officers to seek advice from the senior officer who is married and spend time socially. So she was serving food when they were having conversation, and they were talking about how do I attack my enemy by randomly changing my transmit frequency, and again change the time at which I transmit, and I change my location from which I do my attack. All these concepts of randomization, like a direct sequence spread spectrum, frequency hopping spread spectrum, which became a basis for the WLAN as well as for the CDMA, was originally a thought process that Hedy Lamarr has given to the patent office, which was utilized by the militaries. When America had a challenge from Cuba, Fidel Castro was challenging uh, Kennedy, the president of America, that he would use the Russian kind of technologies with missiles and destroy entire America with their missiles. So they used the white paper that is written by Hedy Lamarr in terms of creating defensive channels, and they used it in an aircraft, and in the jamming pod they went into Cuba and they nullified the radars which cannot anymore see the incoming flights, and then these flights were able to see the radars and destroy the radio communication systems. So modern warfare is that ability of the enemy to wage the war is electromagnetic warfare. And so technology of CDMA was first tested in the warfare, and later Qualcomm, Andrew Witterby, the vice president of Qualcomm, went to the American government asking for permission to use it for peaceful utilization of the technology, which was proven in the war. And so they allowed, and therefore they developed CDMA technology at a time when America was doing the GSM, when Europe was doing GSM, America was busy preparing all the CDMA systems. So very interesting story of CDMA. Along with that, there were two mathematicians, Mr. Walsh and Mr. Hadamard, who are purely mathematicians having no idea about wireless. They contributed to the channels called Walsh-Hadamard matrices, and there were two maths professors meeting each other every Wednesday in America in their own interest of building the orthogonal sequence numbers of a matrix size of 64 by 64. So this is how the OFDM evolved, and we have so that 1200 that I mentioned in the formula, each sinusoidal wave is one of the 1200. These are some of the things that you would be doing, and these are some talks. I would take you through some of the leaders at Qualcomm explaining their technologies. Once again, I'll create noise, and this document I will strongly advise the leaders to share it with all the participants, and for your learning you can use it individually.
As 5G proliferates into diverse applications across industries, 5G V2 Exciting can offload high bandwidth data from the 5G network to deliver new and enhanced applications. In this over-the-air demonstration, we are showing how 5G V2 Exciting offloads the network to deliver high bandwidth.
Okay, just I wanted to create excitement and not really run through all their talk. That itself will take an hour. And this equation is the parent of all the wireless channels, just like for the classical physics Newtonian equations. And at one point of time, world was thinking seriously about WiMAX. 82.16 happened to be the next layer after WLAN, which did not really take off, and that is replaced by LTE, as you all know. And now that is again replaced, going to be another layer on top of it as a 5G layer. These are some of the networks of traditional computing networks like routers, and they are also now in future very little distinction between telecommunications and the packet data internet. So they both will be the same. So when your Dr. Gayatri and others take you through a lot of discussions, they will also talk about computational fluid dynamics and other tools like ANSYS and SolidWorks and COMSOL, and there's a lot of tools on MATLAB. In fact, we work with a few tool makers to help the emergence of the ecosystem like incubation centers. I'm one of the Niti Aayog's Atal Tinkering Labs Mentor of Change, and also for Smart India Hackathons. I'm part of Bureau of India standardization for the UAVs. We welcome any expression of interest from researchers. If they want the license keys for about a year, we are ready to give you free of cost if the need is genuine, which when you purchase will be of the order of something like 66 lakhs for number of users. We are doing it in the interest of the ecosystem, and we are partners with a number of tool makers. So with these few words, I have a lot of other videos as well. And these are is one more leader from Qualcomm. I would spend a minute.
I'm Hemant Sampath here at our Boundless XR 5G testbed on the Qualcomm campus, where we focus on research and commercialization of end-to-end architectures, algorithms, and optimizations for new 5G use cases. Boundless XR uses split rendering to distribute the computation between the edge server and device to deliver truly immersive XR experiences over 5G. Our testbed uses commercial platforms to replicate an indoor 5G millimeter wave XR deployment. The Qualcomm Technologies VR headset reference design, which is powered by the Snapdragon XR2 platform, provides optimized 5G connectivity and on-device processing such as perception, tracking, video decode, and reprojection. The Ericsson G-Node provides a 5G millimeter wave to deliver low latency, high-speed wireless connectivity. The content rendering server executes the computationally demanding graphic rendering to provide photorealistic visuals. We're showcasing multiple VR use cases, including multi-user collaboration and gaming running on a single network. As you can see, users 1 and 2 are in a multi-user VR collaboration. User 3 is using a VR gaming application. We now illustrate the processes involved in a boundless VR system. The VR device sends 6 degrees of freedom head pose data to the edge cloud over 5G. The edge cloud processes this data and renders a new image and then sends the compressed image back to the device over 5G. The device further processes the image before displaying it. The time taken for this round-trip process is called M2R2P, or motion to render to photon latency. The 5G round-trip time is a key component of M2R2P. High latency causes user experience degradation. The user may observe warped objects or delays in the appearance of new objects. Low latency can remove such errors. We now showcase how our end-to-end 5G optimization allow us to meet the stringent low latency requirement of multi-user boundless XR. In this example, all 3 VR players are using the NVIDIA Cloud XR solution and experiencing 2K by 2K resolution at 90 frames per second. The 5G round-trip time is kept below 20 milliseconds and the average 5G downlink throughput is about 50 megabits per second. In real-life deployments, RF and interference changes are a frequent occurrence, which can cause performance issues and latency spikes. In this example, we see a VR user being blocked from the G-Node B by another user, causing a sudden spike in 5G round-trip time for the baseline 5G system. Our 5G optimizations help minimize the latency spike, providing a seamless user experience. In another challenging millimeter wave scenario, the gaming user rotates their head 180 degrees, which causes a sudden spike in our 5G round-trip time. Again, our 5G optimization help minimize the latency spike, providing a seamless user experience. With our system-level optimization, we are making boundless XR over 5G ready for deployment at scale. Our testbed with a single G-Node B with 100 MHz system bandwidth can support 6 simultaneous boundless XR users over 5G and potentially more than 12 users with future 5G features. We have an exciting path ahead to evolve the boundless XR system to include larger networks and augmented reality use cases.
Right. So I have one more talk. And this is going to be the last video talk.
Hi. In today's demonstration, we will be looking at how we can reduce the energy consumption of cellular base stations. Saving power serves two key purposes. First, it can reduce significantly the operational cost, and in addition, it provides an important step towards addressing climate action. In our first demonstration, we will be focusing on power amplifier optimization. Power amplifiers are a major source for power inefficiency in base stations, since they are operated at a very inefficient operating point. If one would try to increase the power efficiency of the power amplifier by reducing the power amplifier headroom,
okay, I would share this presentation to you.
Digital pre-distortion assisted by the mobile phone and digital post-distortion methods in order to suppress the non-linearities induced by the power amplifiers and enable them to operate in the more power-efficient operating. In our demo, we will be using digital post-distortion, which does not require any change in the base station hardware. Here you can see our lab setup, where we are transmitting a signal through a typical power amplifier, receiving the
Shruti, you're there?
Yes, ma'am.
Yeah, something wrong?
No, ma'am, it's fine. Thank you, sir. Session is open for questions. Participants can unmute and ask for questions.
There are some
Yes,
questions.
there are some questions in the, yes, ma'am. There are some questions in the chat box, sir. Shall I read out? Kishore, sir. Kishore, sir.
Yeah, I'm available. Just please ask the questions. Yeah.
Yes, sir. So, importance of OFDM, sir. D. Balakumar.
Okay. I would suppress the behind. Give me some time to suppress the noise.
Yes, sir.
Yeah, now you carry on.
Yes, sir. They have asked for importance of OFDM, sir.
Right.
By Balakumar.
So, okay, sure. Orthogonal frequency division multiplexing is similar to what happened to the computer industry in terms of parallel processing. When a big task is given, computers divide them into smaller chunks, and instead of one after another, they parallelly process them, and then end of the time you get everything added together to your advantage, thereby decreasing the time of processing. So you have to, let us say, look at 1,000 resumes. Rather than one person scrutinizing them, there are 100 executives. They take 10 of the resumes each. They come out with the recommendations and they will filter 10%. Like that, they go about selecting the candidates. So in a similar manner, orthogonal frequency division multiplexing divides the channel into subcarriers, and the task is allocated parallelly to them, and the benefit of the processing gain, basically processing gain is a channel limitation by Nyquist, says that in order for you to retrieve a channel, you need to have the sampling to twice the fundamental. So if you take LTE, your channel is 20 megahertz. If you sample it using Nyquist, you will require 40 megahertz. But by using OFDM, you are using 15 kilohertz, and using the 15 kilohertz, you are using 2048 fast Fourier transforms inside that, and that is creating a sampling rate of 30.72 megahertz. There you are saving 10 megahertz by using this technique of orthogonal frequency division multiplexing. So you are actually beating the limitations of Nyquist by parallel processing and introducing the fast Fourier transform techniques to resolve the channel. So that is the advantage of OFDM.
Yes, sir. There's one more question from Sunita Joshi. Kindly discuss challenges in designing G antenna.
Typically, the wireless 4G is called E node B, and 5G towers are known as a G node B. I assume that you are asking about a G node B smart antennas. To design an antenna, you need to have the technologies such as like a VLSI design concepts and a microwave fundamental like microstrip, and you have to model it in some EMI EMC chambers. There are softwares to ensure your design is not likely to have EMI EMC problems. I think Keysight also has ability to test EMI EMC, and tomorrow, day after, and including today, they will touch base on some of those facilities, the presenters.
There's one more question. What are the issues and challenges faced if we increase number of nodes in ad hoc wireless networks? From Jamal.
Yeah, always there is a the thin line between centralized communications and the decentralized communications. By decentralizing, you encounter more number of decision-making points and channels. It introduces more noise, and at the same time, per node, the flooding of packets is minimized. Therefore, there is a balance that you need to strike between the chaos that would eventually result by the number. So something like chaos theory, when randomization increases beyond the limit, it results into chaos. But the physicists also say that when you enter into a state of chaos, you keep calm and then normalcy sets back in again. So again, as the random variables increase, order sets in. That is how the systems are robust and they're designed. So the number of nodes in a wireless sensor network is likely to give you more kind of a ability to deal with a complex problem, but at the same time it introduces the challenges of needing to handle the multi-channel concentration. And by using advanced 5G techniques, since it is capable of handling multiple channels at a MIMO, you will be able to again bring normalcy by using those techniques. So you can look at the problem statement of multiple nodes as the model involving 64 by 64 QAM system. So you can actually relate with that and then solve the problem.
Yes, sir. So there is one more question. What is the impact of 5G on fiber requirements? From Professor Anjana.
Yeah, yes, Professor. So in fact, very interesting evolution that has taken place even during the 3G days is inside the architecture of a base station. Between the radio device and the electronics, they introduced, instead of a RF cable, where the cable, if it fails, they were supposed to do voltage standing wave ratio test, and the cable was very heavy and very difficult to handle in terms of logistics and also cost. They replaced that with CPRI cables, common public radio interface. It was giving 1228 megabits per second data rate. That CPRI has undergone tremendous transformations. Now CPRI version 5 and then M code has come, and literally all the connections inside 5G, they're all fiber optics, and also between the 5G radio to the core is fiber optics. So going forward, everything will be fiber driven, including the free space propagation, laser beams connecting buildings, and so the non-terrestrial communications of 6G, Li-Fi is also going to be like an evolution of what happened in the fiber optics without using the fiber cable. So that is the importance of the optic fiber contribution to the wireless technologies. I've written a white paper about convergence of Walsh codes and the virtual containers used in the SDH, and it received a lot of appreciation from the research community.
There's one more question from D. Balkumar, sir. 14,000 multiplied by 12,000 multiplied by 6.
No.
1,200.
14,000 multiplied by 1,200.
1,200, they've taken as 12,000.
Yeah, 1,200.
Mr. D.
Because in a 20 megahertz channel, you will get 18 megahertz for the usage and 2 megahertz as left and right as guard band. 18 megahertz divided by 1,200 is 15 kilohertz, and that is a sinusoidal wave which is used in the Ofdm ensemble.
Mr. D. Balkumar can unmute and continue with this question if it is not answered.
So if you raise your hand, yes, ma'am, we'll do that.
Yeah, I think that was a continued question, no?
Yes, ma'am, it's a continued question. I'll just unmute them, ma'am.
Sir, good morning, sir.
Yes.
Sir, it is 14,000 in 1,200 into 6. In that 1,200, you told that a subcarrier. What about 14,000 and 6, sir? Just I want to know that one.
Yeah. So 14,000 is the number of the number of symbols emitted by the chipset. So every millisecond. So if you divide a second into milliseconds, you get 1,000 components. So every millisecond, you will generate 14 symbols by virtue of the Qualcomm chipset designed for LTE. So 7 plus 7. 1 millisecond is also utilized as 0.5 millisecond 7 symbols. That is how the chipsets are designed for LTE. So 7 symbols plus another 7 symbols is 14 symbols per millisecond. Therefore 14,000 symbols per 1 second. And the 6 is 2 raised to the power of 6 is 64 QAM. In an ideal condition, the LTE channel can give up to 64 QAM. Therefore, one symbol can be resolved into 6 useful bits. Therefore, 14,000 symbols, and that is coming from every other 1199 other sine waves also, in addition to your sine wave. And every symbol can be resolved into 6 useful bits. Therefore, 14,000 multiplied by 1,200 into 6 gives you 100 Mbps with a single antenna in case of LTE channel.
Thank you, sir.
So there's one more question. What are the latency issues faced in MIMO by Professor Vinay Kumar?
Yeah, sir. Latencies of 5G are far superior to 4G. Typically, the 1 millisecond latency is what is expected out of the ultra low latency reliable communication paradigm. Having said that, that is the mathematical 1 millisecond latency. Plus, you need to add the propagation delay, and which would be like a few milliseconds, and also to do error processing and the correction judgment of the rake receiving like things. So instead of 1 millisecond, which is the textbook result, industry has reached a stage of like 10 millisecond in the practical implementation. So ideally 5G is supposed to achieve 1 millisecond. Probably the task will be given to the 6G by more advanced techniques, including Li-Fi and also the channels like a visual light communication, which is also candidates as for IIIT Delhi and TSDSI. They are trying to introduce because the RF channels are fast becoming depleted. Even though you pay a lot of money for license fees, all these RF channels are fast becoming occupied, and mankind wants more and more. In Hindi, they say dil mange more. So you need more and more channels, but you don't have resources. Therefore, by using the light fidelity and visual light communication, we are trying to solve those challenges. So the delays that are there in MIMO may be due to the fact that you have got data that is coming from different MIMO instances. Let us take two extreme examples of MIMO in terms of delay calculation. When conditions are very good, MIMO is used for spatial multiplexing concept, which means that every antenna is giving you new information. Let us say Bahubali 2. So if you download using a 64 by 64 antenna, every portion of the antenna is taking one portion of the movie where the elephant is doing some magic and you are so happy, and the hero is climbing on the hood of the elephant, so that every portion of the video is in one of the antennas, and quickly you get all the 64 combined. That is called spatial multiplexing. But when conditions are not so good, there is a dust and a lot of environmental degradation of the channel. So what happens is all the 64 antennas will transmit the same data. It is something like a child is lost in Amazon forest, and parents are rich, they have helicopters, and they have got a print of telling the child what to do. They print a millions copies of what the child should do. They don't know where the child is. You do random movement of helicopters in the forest. You don't know where the child is. There is no mobile communication, and he is lost due to some reason. And what do you do? Then out of your 1 million papers, you expect one paper that is dropped by the helicopters will be picked by your son or a child, and he will be rescued. Similarly, in the case of bad RF conditions, MIMO will be, the delays will be such that all the antennas will transmit the same data because the conditions are not good, hoping that at least one of them would perform good. So that is where the delays will vary. When all conditions are good, delays will be less because processing complexity will be less in correlation. Whereas in case of multi-channel propagation and MIMO with transmit diversity rather than spatial multiplexing scenario, delays will be more in a noisy channel model.
Thank you, sir. Yeah, there are no more questions. Okay. Now I call upon Professor Chetan Anand to deliver vote of thanks.
Okay, thank you, Shruti Madam. Am I audible?
Sir, you're audible, sir.
Okay. Good morning, everyone, and one and all present here. Honorable Chief Guest, Flight Lieutenant Sri Annam Tyagaraja Kishore.
Thank you.
Sir. Respected Principal, Dr. M.U. Ashwath in his absentia, and Dr. Shantala, HOD, Electronics and Telecommunication Engineering Department. It is an honor for me to get the opportunity to thank you all dignitaries. On behalf of the Department of Electronics and Telecommunication Engineering Department, VIT, I would like to express my gratitude to all esteemed delegates of the 3-day workshop on design and simulation of wireless communication systems for their presence and making this inaugural function a success. A good beginning is half done. It was an extended session of keynote address. I would like to extend my gratitude to Honorable Chief Guest, Flight Lieutenant Sir Annam Tyagaraja Kishore, to take out time from his busy schedule to grace the event and deliver the keynote address. Thank you very much, sir. Not just delivering the keynote address, he has taken his time and he has continued with the patience of addressing the queries put forth by the participant. We as organizers take pride in organizing this workshop, which has attracted the attention of the participant, and it is evident on the inaugural day itself. Thank you, sir, for your keynote address. On this special day, I would also extend my special thanks to Dr. Gayetri, Application Engineering Arts, Mr. Muthu Kumar, Application Engineer Arts, as well as Mr. Srinivas for their presence. And hopefully, as for the schedule that has been made, they will continue to interact with the participant addresses in the days to come. My special thanks to Dr. M.U. Ashwath, Principal of BIT. He couldn't be attending this function because of some preoccupations, for providing immense support to make it possible to organize this 3-day workshop. I also try to extend my gratitude to Dr. Shantala, Head of the Department ETE, in organizing a workshop even in amidst pandemic. I must thank the organizing team comprising of the coordinators, Professor Shruti and Professor Ranjana, to come up with a schedule which is very convenient to all of you and having attracted many participants across the state. And also the volunteers for working hard in past few days to make this webinar or the workshop more successful. Thank you everyone once again for all making it a great success. Thank you.
Thank you, Chetan, sir.
Thank you, Dr. Chetan.
Thank you, sir. Now, ma'am, can we continue the session now?
Yeah, so thanks from my side also, sir, to the chief guest.
Thank you.
I'll get back to you, sir. Thank you very much.
Thank you.
Thank you very much, sir. The session will be continued. We'll continue the session by the forenoon session. Session will be handled by Mrs. Gayetri, Application Engineer from Arts. Gayetri, madam.
Yeah, ma'am. Ma'am, I'm audible?
Shall we continue? Yes, ma'am, you're audible.
Yeah. Okay. Ma'am, shall I start?
Yes, ma'am, you can start. You're the host now, ma'am. You're made as a co-host. Can
No, 1 second, ma'am. I'll. Ma'am, is my screen visible?
Yes, ma'am.
Something went wrong. Ma'am, just a second.
Yes, ma'am.
Ma'am, just a second. I'm sharing my screen.
Yes, ma'am. We are not yet able to see. We are not able to see, ma'am. It's a blank screen. Yeah, now we are able to see, ma'am.
Ma'am, are you able to see my screen?
Yes, ma'am, we are able to see the ma'am. Your mailbox, it is actually.
Mailbox?
Yes, ma'am. Previously, we saw your slide. At present, it is a mailbox, what we are able to see.
Now?
It may take some time.
No, not yet,
No, ma'am,
Gayatri.
not yet. Not yet, ma'am. Yes, ma'am, we are able to see the PPT.
Yeah, okay, fine, ma'am.
ನೀನು ನಾನು ನಿಂತ್ಕೊಳ್ತೇನೆ ಆಮೇಲೆ ಲಾಕ್ ಮಾಡ್ಬಿಡ
Ma'am, hope I am. Are you people able to see my screen, right? PPT,
Yes,
sir?
Gayatri.
Yes,
Yeah.
yeah.
You
Thank
can
you, sir.
proceed. Yeah.
Yeah. Okay, thank you. I hope I'm audible.
Yes, ma'am, you're audible.
Fine. Good morning, all of you present over here. So
Yes,
today
good
I'm
morning,
going to give more insight about the Keysight software. So what are the availables that with respect to Keysight? So I'm going to give a brief about the ADS and deeper insight with respect to system view. Fine. So myself Gayatri, an application engineer applied RealTech system. And along with me, my colleague Muthukumar J. He is also present. He is also application engineer from Arts. So this is my agenda. So I'll just go with respect to introduction and the evolution of the software of Keysight and what are the software that is used by the designer or the right person and what are the products and the competitive. So I'll give just introduction about my ads. So ads, it's an applied RealTech system. We do support for distribution of Keysight products. And we do supported design and test integration, manufacturing products, and even AMIMC simulation products, automatic components, and noise figure. And we have even different handset antenna test. We do support for all this. We have multiple application engineers, and we have a different teams. We have. We do support it radar test, electronics warfare. We do support it satellites. We do support it signal integration part. So we do support it designing RF circuits. We do support different digital RF communications and antenna propagation techniques. So with respect to the Keysight, if you want to be in the best in the market or you want to be first in the market, I would prefer to be use a Keysight products. Fine. And Keysight product not only supports a hardware component, it also supports a different software components, and we call it as a pathway. And we not only supports a product or the software, we do provide a service. Right? We'll see what means how exactly the software is evolved. Right? So earlier the Keysight software is called as a automation tool, that is electronic design automation tool for designing the communication products. Right? And this EDS tool, that is EDA, the software tool, is also used by microwave to design microwave and RF circuits, even at high-speed devices, even for device modeling, and even for the signal design processing. Right? So it is evolved from 30 years. So in each and every year means there is a change in the library files, and each and be updated in the library files. So we do support, the software supports 2D, 3D, and even this has a different types of simulation technologies it uses. We can measure S parameter, we can measure different X parameters, fine. And even this software supports third-party vendors also, design library files. Right? I said this is earlier it was called as a EDA tool, and again it is being modified and it's called as a ESOF, electronic engineering software. And then again this is modified and it's called as a pathway currently. Okay. So it was introduced, it was founded by Charles J. He was a software engineer, right? And the current ESOF, whatever the pathway we have, first ESOF is first acquired by HP in 1993, and later it was acquired by Agilent Technology in 1999, and then it is acquired by the Keysight Technologies. What are the software that is available with respect to the Keysight currently? Right. So for example, I'll just give one example. If you want to model any system, what are the basic things you will consider? When you want to model like any kind of a system, first, what are the things we are going to consider? We are going to consider from the scratch. From the scratch means what we want? We want a physical system. Like what exactly the physical terms we want? Fine. So based on our physical system, then we are going to assume. So what you are going to assume? Whether our module to be a linear or to be a non-linear. If it is linear, what are to be considered? And if it is a non-linear, what should be considered? Fine. And once you consider what type of the module, then you are going to apply different types of laws. Right? After applying, you are going to find a mathematical models, and then you are going to get the final solution. Right? Once you get the solution, then you start with the designing either by the software or either by the hardware. Right? So now to design using the software, we have different types of software that is available with respect to Keysight. Right? So what are the different types of software that is available? These are design software, test software, application software, library and plugins, and XCA products. Right? So I am going to deal only with respect to design softwares because these are the simulation software that you are going to do. And the test software, what we have, it is with respect to the hardware part that we have. And even this application and library files also, this all with respect to the hardware parts. Okay. So some examples with respect to, I hope we have, like in some of the colleges, they have the instrument like vector signal analysis or signal generator, like oscilloscopes, right? For those, what are the software that is available? That is all called as test softwares, fine? And for the test software that we call it a vector signal analysis, and that's come with a part number 89600, right? Again, we have for different applications, we have X series measurement for different applications, and even we have a bench view, right? And we have different types of software application, application softwares like for oscilloscope, for Fox field Fox handheld analyzer. We have like different kind of softwares, right? So these are the different softwares with respect to different products. So I'll come with respect to the design software. So with respect to the design software, we have again classified into different softwares. One is RF and microwave software. One is with respect to high-speed digital, and another is power electronics, system level design, and device modeling. Right? So we'll see one or the two softwares for designing our content. Okay. So we'll see what is RF microwave in what are the different RF microwave softwares that's available in Keysight. One is advanced system design called ADS, This advanced system design is completely basically a circuit design. We can start from the scratch, from a basic low pass filter to high end design. Right? We can do all the in ADS, all the circuit simulations also we can do in ADS. Even our method of movement simulation that we can do in EMPRO. And EMPRO also supports EMI EMC compliance simulation. It also we can do EMI EMC simulation in EMPRO, right? In RF synthesis, we can go for the PCB design. And in RFIC design, this is RFIC nothing but a golden gate. We call it a golden gate. This is used for RFIC design. And another we have a thermal design, which is used to measure the temperature of the chip. Okay. And where the interconnection that all goes, no, that can be done in thermal design. So this is about the RF microwave. So I'm going to do here. I'll just give brief about the advanced system design, and then I'll continue with the system level design. Fine. And this is with respect to RF and microwave. So this is how it ADS, and this is system view. So I'm going to cover the entire content what madam has designed, which EIT has designed. So I'm going to cover using system view. I'll just give brief about the ADS. Okay. So we have, like I said, this is how it looks. So this is golden gate. So in this software, what is the simulation technology that uses? So we have all these, whatever the softwares that there's all of the simulation softwares. ADS is also simulation, system view is also simulation, EMPRO is also simulation, golden gate is also simulation. But what are the simulation that you are going to do? It gives an accurate result with respect to your design. Right? So we have different simulation technologies that all the software uses. One is a method of movement, another is finite element method, FEM, and another is finite difference time domain method. So we have 3 different technologies it supports. ADS supports, and when you are going to use ADS with EMPRO, it supports with FDTD method. You can design your antenna in that is EMPRO, as well as in ADS. Once you design your antenna in ADS, that can be called in EMPRO, so that you can design FDTD. That is, you can do simulation using FDTD method. So this is just a basic difference about the method of movement. It is used for a planar. Method of movement is for planar and passive circuits. And FEM is also, it's a frequency domain, and it is used specially where packaging is done and wire bonds, right? And finite difference time domain. It is a time domain method and used where our wavelength is large, such as antenna. Okay. So I'll just give brief about the ADS. So it is very much easy, right? And it is electronic design automation tool, which can be used for RF design, microwave design, high-speed digital applications, right? And it is also, it is used for designing a circuit design. It is also used for layout, right? It can be used for co-simulation, right? It is also 3D EM technologies. It is also used for IC packaging in PCB, right? And it also supports different types of library files. For example, radar satellite applications, it can be used. Okay. So I'll just say, means whatever this feature has mentioned, I'll show in terms of the figures, right? So first point is what it is used to capture the schematic, and it also used for designing, means you can do layout design also, fine. And it is a system as well as a circuit simulator. It is different type. It has a different types of solvers, and we support PDK files, PDK, I'll say what exactly this PDK while going through for the slides. And this is also integrated with the different companies. And it is used different optimization technique. And it is also used for X-parameter modeling or generation for X-parameters. And we have up-to-date library files still today, even 5G library files available with respect to ADS. Okay. So this is what they just I showed in the previous slides. So I said no ADS. It is a complete circuit design we can do from the scratch. The ADS means using ADS we can do circuit design from the scratch. We can do normal low pass filter or using we can do from the start using RC circuit design. We can do all the things to the high end. Fine. So what it is, we can simulate here S parameter. We can do circuit envelope. We can do transients. We can simulate with respect to transient or with respect to X parameter or with respect to signal integrity. Okay. So this is how exactly your graph looks when you're going to design and when you're going to display your when you want to see the result. Right. So I said it can be integrated with different vendors. So it can integrate with the Cadence. Right. That is, we can integrate with respect to Cadence or Zuken or Metagraphics. Right. And nowadays, even like Synopsys also supporting with respect to, Synopsys also in hand with the Keysight currently. Right. And these are the different foundry partners, nothing but our foundry partners here. What we are doing here, this is a third party. What you are going to design. For example, if you design your circuit, and for example, if you design your capacitor, a basic capacitor, and that capacitor, what is producing the value, that can be checked with your third partner. That is called a PDK file. We are going to call it a PDK, that is process design kit. And we are going to use, you can transfer file with PDK files, that is ideal values with respect to your design value. Okay. That is our, so I said no optimization technique. In ADS, we have a different optimization technique, and those are the 12 optimization technique we have. We have a cockpit, that is which modifies the value with respect to your design, and then it will give display over here. You can see in this box, there's a green color which is modified, and the value this is modified here. That we can be seen here. Fine. So this is optimized. We have different types of optimization technique here. So according to your design, you can use different optimization technique such that you get a proper result, desired result according to your design. So this is if you want to design an antenna and if you want to simulate FDTD, that is finite difference time domain, then you have to have a EMPRO software with ADS. Then only we can simulate FDTD. Right? So this is how an advanced system looks initially. And when you're going to open your advanced system design, this shows what all the things it is available, means a folder. And this is where exactly stored your design. Right? When you open another pop-up window, it will show what type of workspace you want to create. You can create like a name of your workspace and where exactly you want to store. Right? And this shows technology, what can be used. You can use existing library files with respect to RF or the DSP part. If you're going to with respect to use a DSP, then you have to check box. Right? And I said no, with respect to demo, like existing part, then you can check with ideal value and your design value using demo kit. Fine. And we can have other things. And this is a resolution such that your schematic means for your design it is required. What of resolution you want to use? What that it is used here. These are the resolution technique that can be used for ADS, and you can use for PCB and you can use for different. So how this is exactly looks? This is a schematic where you are going to design. To design a schematic, already the components are available here. You can see here lumped components. It is just mentioned here lumped components, nothing but it is R, C, L, C. Different components are available. Just click and drop here. Click and drop here, you will able to design. And if you want to click register, you place the register on this schematic, and you can change the value of your register according to your design. Fine. Even you can change the value of the number. If you take a capacitor, you can change the width, length. That's what was available. Temperature of this capacitor can be changed, modified over here. Right. So for example, if you want to see like a different palettes, I mean, simulation available or the source available, we can see at this. This is called a palettes, we are going to call it as. So this is earlier this was schematic. Fine, this is a schema. This is a schematic design where you can do circuit design. Suppose if you want to do a layout to design, so this the window appears like. This is the window appear. This is your layout design schematic, and this is all the related part numbers, means components that you can use to design your layout. Okay, I just gave one example like with respect to microstrip. I just took here, right? So this is one example using a QPSK, that is, you can see basic means normal system level design can be done, not to the higher end, yeah, but to some extent we can do system level design even in ADS. This is one example with respect to QPSK. So there are multiple things are there. This is a filter design using a schematic, and this was a schematic. This slide is a schematic, right? Schematic design. This can be easily converted into layout directly just clicking by one. Just go for this is layout. This is a layout. Just click on the layout, generate. It will generate. This whatever the schematic has been done here, the same thing is here in the layout. Everything just converted into layout. Just one click. Right. So this is where display. You can see different type of display your result. Like using a Smith chart, rectangular plot, or you can write your own equation. Fine, you can form the tabular column. Everything can be done here. Okay. So this is one antenna example design, patch antenna example design. So the multiple antenna, this some cross. Right. So this is about the ADS. This is actually okay. This is about the basics about the ADS. So who all can be used this ADS? Yes, these are the people can be used by RF and micro designers, especially the board designers or the system integration designers or the power electronic designers or the signal integrity designers, MIMC designers, RFIC designers. This ADS can be used. Fine. So this is where aerospace people, aerospace and defense, you can MNC people also uses. Even in education, some education colleges are using ADS. Right. So ADS can be used for as well as UG project or PG project as well as in the research for simulation, and it gives a proper accurate result to your design value. You can check, you can cross verify your design value. If you are not getting a proper value, then somewhere something you are doing the mistake while selecting the value of the particular component. Right? And this ADS can be introduced in your any of the laboratory. Right? So these are examples application of ADS. We can use in the different solder bumps. And can use in the turbo temperature. Even you can use it multi-chip models. You can do for chip design also. Okay. So ADS, if you want to check your proper result, then you use your ADS and then put into the hardware place. What are the result that is you can see in your hardware part. Then you can check whether the value is accurate or not. Okay. Okay. Now I'll come with respect to the system view where we are going to do hands-on session using the system view. Fine. I hope everyone who have given their Mac ID, we have provided license. I think everyone has installed the software. Shruti ma'am? Muthukumar sir? Am I audible?
Yes, ma'am, you're audible.
Yeah. Ma'am,
ma'am, can you keep your mic a little bit closer?
Yeah, okay, okay. Ma'am, I would like to know that the Mac ID is even provided by you, or all the participants has installed the software. Can you confirm?
Those who are given a Mac ID, they have installed, ma'am.
Yeah, fine, fine. Okay.
Shruti,
Yes,
madam
ma'am.
is not audible clearly. Not audible clearly.
That's what I've informed, ma'am.
Very low the voices. Very low the voices.
Gayatri ma'am?
Ma'am, now?
Now also a little bit.
Now is okay?
Yes, now it is okay,
Very
ma'am.
little.
Okay.
Okay, slight improvement, that's all.
1 second, ma'am. Ma'am, now is okay? Hello?
Can it be increased further, madam?
Ma'am, this is the last, ma'am. Completely have increased.
We are able to
And
hear.
probably you should be close. You should be close to the mic, I guess.
Yeah, ma'am, I'm very close to the mic.
Yes, ma'am, we are able to hear actually.
Okay.
They have posted in the chat box also that it is audible.
Yeah,
Okay. Okay. Thank you, madam.
Okay, ma'am. Shall I continue, ma'am? Actually, my volume is full. And
Yes,
my
ma'am. You
my
can
throat is
continue.
also full, ma'am.
Yes,
Yeah,
ma'am. You
okay,
can
ma'am.
continue, ma'am.
Okay, I will start with the system view. What exactly the system view? And I'll give more insight about system view. So it is a system is nothing but it's a system level design. And we can, using the system level design, we can do all the basic system level design to the higher extent level design. And in current system view, all the library files are updated, fine. So with respect to even 5G library files is updated, we can design a RF architecture, we can design with respect to 5G modules, or we can design radar, means we can design radar things, and even we have we can design even antenna array. Okay, antenna means already all different library files are available. We can just use, and then we can modify your some of the things according to your design, and then we can use for further. Okay. So what exactly the system, who all this, what is exactly the system view? System view is nothing but it's just a simulation. It is a simulation platform. It's a system simulation platform. So where it can be used with respect to the baseband and analog or RF design, or the different type of channels, or the where we can design all these things. Okay, means we can 1 sec, ma'am. So I said, no, this is a simulation platform. Okay. So we can use it a baseband, analog RF, and different type, different environments. Okay. So who are the target application means what are the target applications for this pathway? We can use it aerospace and defense. You can use in the like upcoming communications like 5G, even like if for the 6G also the library files is still building on, so we'll get as day passes we'll get different library files. And even current trend is automotive, we can use in even automotive. For example, in our case of automotive, you can use at the radar or at the communication or the vehicle to vehicle communication. That part also we can do here. Okay. So who all the uses system view? That is wherever you are in the design at the base level or the architecture level, then or at the system verification you can use. Okay. So this is what you are at the system architecture level or the baseband level or at the system verifiers. There you can use the system level, system view. Okay. Wherever you are in the design, no worry, you can use system level design. That system you can use. And so what are the things we can do here? This is a just a overview of the your system view design, system view software. So this is for designing the system. So for example, this system view not only supports for coding using a MATLAB, even C++, even HDL, and even Python also it supports. ADA supports Python. Okay. So this we can do coding, and we can, this is all the input part. So you can input and you can do design all the from amplifier to like if you want to do circuit level design of amplifier, then you have to use ADS, and you can call that ADS designed circuit in ADS to system view. So this part we can do all the things. And so this we can all see even with respect to channel fading and receiver. And if you this can all be done in system view. Okay. I said, no, wherever you are in the design flow, so this is, yeah, here. It will support. Fine. System view can be integrated with a different, like I said, no, MATLAB, it supports for MATLAB. You can, even it supports a different measurements, and even it supports with a different type of softwares that is available with respect to any hardware components, and even we have this, all the hardware designs it supports. Means we can call these instruments in system view and check your real-time signals, what you have designed. Fine. For example, this is one example. This is a one screenshot which took for radar design. If you want to do radar design, you can create a radar system level design in system view. Once you create a system level design, if you want to see animated signal, means animated kind of design, then we can use SDK from AGI. SDK software, where we can see animated signal. When there's animated kind of what I say, animated models. For example, if it is see, we can see the aeroplane. That kind of we can signal, see what are the clutter, means target, whether this target is reaching, this radar is reaching different things or not. That part we can see in the terms of animated using a SDK. This system view supports a third party software also. That is what it is indication. You can do coding using C++ or HDL or MATLAB. Fine. And this is FBG array. Fine. So now we'll start with respect to hands-on session using the system view. So I hope everyone, means who are installed, please open your system view.
It's participants, those who have downloaded, please do, if any queries are there, please do let us know. Madam will answer. If you're facing any issues in installation as such, please do let us know.
Actually, it is not visible on the application list. It is showing as KS Keysight ES tools, like that it's showing. Where exactly to launch this app?
Is Gayatri ma'am?
Yeah, ma'am. Yeah, ma'am.
Because in desktop we don't find any shortcut for that.
Ma'am, you have to while installing, you have to checkbox the shortcut key. If you did not check the shortcut key, then it will be in the C folder. You have to search and you have to open, ma'am.
Okay.
Madam, see in that main windows, if you click the windows, you will find pathway this name system view. You can double click on that. We can launch that application.
Okay, sir. I'll just check that. Yes.
Yeah, who are facing any issues with respect to installation, myself and Muthukumar are here to support you so that you can install and we can continue with the hands-on session.
Yeah, yes. So if you are facing any challenges, let us know. We'll support you on that.
If already installed, if already installed properly, can I continue or shall I wait for till you install?
I think, ma'am, you can continue.
Yeah, okay, fine, ma'am.
Because anyhow in the afternoon session also it is hands-on. By that
Okay.
time they can.
Yeah, fine, ma'am. So, okay.
Okay, ma'am. In program files, we have two apps. One is AGLM MGR and AGLM P reference. Which one to open? In license tool, this thing. AGLM tool.exe. Is that one?
No, ma'am, it is nowhere.
No, madam. You will find system view, the name itself.
System view. Okay, sir.
Yeah, yes.
It's not in the system. Okay. No, sir. I'm not able to find. Okay, you can. Can you help me offline, sir, so that others can?
Yes. Yeah, definitely. Yeah. Yes. Give me 2 minutes, then I will.
Yes, sir.
Shall I continue?
Yes, ma'am.
Yeah. So when you when you click on your system view, it's look like this. Fine. Listen, all of you, please pay attention over here. how exactly it looks. Once you installed, when you're going to click on system view, this is the screen that will pop up. Okay. Once this is a screen pop up, you will get a license agreement. Once you pop up, you will get a license agreement expiring within so and so days. Right. You just say okay and then go for it. Then once you say okay, then you will get this kind of a screen. Like initially, this is entire. I'll show another screen. This is a basic about the system view. I'll say about this and then I'll go with the screen. Okay. So this is what this is screen is sharing here. Currently, it is a system is schematic. This is called as a schematic, right? And this is a part selector where you have already designed parts that you are going to drag and drop in the schematic. Then, according to your design, you are going to modify the different terms, and then you are going to simulate, fine. And this is a workspace where you are going to save your folder. That is where means where your folder or the design is going to store, and it also displays not only schematic, it also displays the graphs and your analysis of the schematic means design. Okay. So this is a part selector where this is shown here. I showed this is a part selector. There are different types of part selector, means nothing but a library files. In this library files, you can see different CDMA parts, fine, and Flex Ofdm parts, HSDP, LTE, MIMO channels, radar, RF design, system design, WiMAX, WLAN, different parts, library files are available. From that particular library, you can select what you are means according to your design, you are going to select a particular library, and from the particular library, you are going to select your parts. Okay. So what are the capabilities of the system view? So it is very accurate. It is a speed compared to other software. It is a speed is more, and it is very accurate, fine, and it's flexible also. And even it keeps a track of your all the designs, fine. For example, if 8 designs you already run and close this window again, when you again open, it will display all the 8 window means 8 designs are available in the main screen window. Okay. And it is very easy to use. So we'll start with examples. I'll stop sharing the screen currently. Can you see this screen? System view?
No, ma'am.
1 second, ma'am. 1 second. I'll share another screen. Are you able to see my screen?
Yes, ma'am. Yes, ma'am.
Is it a system view screen? Welcome to system view.
Yes, ma'am.
Yeah, okay, fine. Okay, I said now when you are going to open the screen, system view design, I mean system view software screen, it shows the system view, and then another pop-up window gives with respect to license agreement. After that, clicking, you will get another pop-up window, and this is a screen. Fine. So this screen is representing welcome to system view. Fine. So it all gives the information getting started for MATLAB scripting, part wiring, and AMI modeling. Okay. Then after this, if you want to see tutorial videos, you can see tutorial, or want to see play videos, you can see play video. And what all in the latest version, what are the new things to be added? This can also be seen using here. Okay. Now, I think all of you opened. Then please close here. You can see even additional videos in the YouTube, right? So currently I'll say close. Once you close that part, you will get, I said no, 8 I done the previous things. These are the things I have done. So it is displaying over here. Okay. So if you don't want to use the already existing work file, then you can go for selecting the new file. That is a blank. If you want to use, you can use a template. If you use a template, what will be display? That means it will display basic things. And if you are going to use a data flow with respect to RF beamforming, or the RF architecture, or the RF link template, we can use different type of templates, or you can use a blank. Fine. I'll show one example with respect to template, what it displays, and after that I'll show is a blank. Okay. So I'll say one example. I'll not do anything. I'm just choosing a data flow template and I say okay. I'm just making you familiar with the system and then finally I'll go with the hands-on session. Okay. See, when I pressed on the template, so what it already is showing here, I'll just close this all. See, this is a data flow template. It gives a notes, means description about the data flow, design, how it can be created, fine. And this is your where schematic. In the schematic, it is I'll just fit the window. See, in the schematic, what is there? Just there is a one sine signal. Then you are going to see the output either in terms of spectrum or the normal signal. Okay. So I'll bit zoom this. See what is here? One signal, sine signal. Then this is your sine wave, fine. And this is your spectrum analysis. You can see in terms of spectrum or the normal signal. Okay. So I'll minimize this. And then this is a signal which is showing. This is a 1 to 3 sync. I said no. This is normal sine signal that we can see with a different time scale and a different amplitude. And
Madam,
this
can
is
I know
another.
this is the output of diode?
No, sir. It's just an example of sine signal. No, not a diode.
No, madam, sine signal you are giving where? This output spectrum is of.
Sir, this is a schematic.
Okay.
This is where I took a sine signal. I'm not doing anything, just displaying a sine signal in terms of a spectrum and in terms of the normal sine signal. This is 1 to 3 is representing as normal sine signal, and this is spectrum analyzer expressing in terms of the spectrum. Fine, sir?
Thank you.
Yeah, I see, sir. This is in terms of spectrum. Fine. And this is in normal 1 to 3. It is in the output. I'm just took one template. I like designing anything. I'm just gave what exactly the template looks like. Template gives the complete information about the particular design, basic designs. Fine. So once this is, I said no, these are all the things it gives. And here work in the workspace, we can see here what is the name of your file. This is a data flow template and what type of design. Your design is a schematic. Fine, this is your design. This is a like a amplifier design. That is, it is nothing better. The symbol is amplifier, right? So or the op amp I can call. So this is a design. Design name of the design is design 1 and it is a schematic. Fine. Once you run this, you will give analysis. And in analysis, what all it do? It will display all your required. I'll just press on this. See here, you can say start time and stop time, sample rate, number of samples. Number of samples can change with respect to your according to things. These are the samples can be chosen here. Okay. And what is the time spacing and frequency resolution? Fine. See, this is indicating here these lines corresponding here. If any change in any of these things, there is a change. For example, if I change here 128, see, there is a change. No, you don't need to modify by yourself. It will change button. If you choose any of the thing here, if I choose anything, it automatically modifies. No need to worry. Yeah, but if you want, you can change this here. I'll just say 5. It will change. Right? And if you want to run, calculate now. If you press on calculate, it will show your result. Fine. And so this is, and you can display different types of graph. I said no 1, 2, 3 and a spectrum graph. Fine. So this is just a template I showed.
Excuse me, madam. Can I ask one question, madam?
Yeah, sir. Yeah, sir. Sure, sir.
Madam, suppose if you are giving the signal and if we connect any like a device like a between this spectrum analyzer and I want to see the spectrum of that, is that possible?
Yes, sir. It is possible, sir. But it should be present in our system view or library files. The device part.
So maybe some.
Yes, sir, you can see, sir.
Okay,
If,
okay.
for example, if you are going to use a vector signal generator, that part number should be
Yes, yes,
able to support. Yes, that should be able to support
yes.
in system view. That should be present in library files.
Okay,
You
okay.
can
Thank
see,
you.
sir. You can see.
Madam, a little bit brief me what like a device we available in this library file.
Yeah, yeah, I'll come to
Like
that part,
suppose
sir.
some. Okay, thank you,
I'll
ma'am.
come
Thank you.
to yeah, sir. I'll come to that part, sir. I'm just giving a base what exactly the template corresponds to. Fine. I'll just close this entire thing. I don't want to use this, so I'll close this. I'll take. I'll close workspace. Fine. Okay, when I close this, again, I'll get one more pop-up window. I'll use a blank and I'll show all the description and finally I'll go for the design. Okay. So I'll use a blank. I'll say okay. So when I say blank, see it displays a workspace. What is I choose selected here? It's a blank. Workspace name is blank. If I want, I can change the right click on the blank and change. Oh, sorry. You can add number of folders. You can add the folders or you can select the analysis, or these are the things you can check over here. Okay, graph, you can plot graph, or you can write a scripting language, or you can plot the result in terms of a table also. That part also you can do. Okay, I'll say here, and even write equation also. And this also supports MATLAB. You can write MATLAB equations here. Just click on this equation and you can write a MATLAB equation. See, this is a MATLAB scripting. Directly it will appear. You can write according to your design, or if you want to write any kind of a coding with respect to your design, you can write over here. Okay, just click on this equation and then write. Okay. Okay, I didn't select this as a, I said no library files, different library files that we have in a system view. So this is called as a part selector, fine. And what are the library files that is available is, see here, these many library files are available here. See, these many library files are available. That is the general design, and this is already absolute is not available here. Analog devices, right, with respect to system parameters, automotive radar parts, Bluetooth parts, CDMA parts, CDMA 2K parts, coilcraft, custom. There are multiple things are available. This is an instrument, Flex Ofdm parts. This is one instrument that can be integrated. I mean, so that can be used to see your result also. Okay. So GNS part, GSM parts, different HSDPA parts, LT, MIMO, radar, RF design, WiMAX, WLAN. So currently it supports different WLAN parts, fine. And this, so these are the different parts that is available, fine. And even my system, my software is 2018 version, so it is not showing 5G library parts currently. Okay. So these are the different parts that is available that can be used, right? Now again, if I say general, I'll say general, and if I say all, again in category, if you want to select, if you don't know any part numbers properly, then you can use all, and then you can search here, filter by, you can search here. If you know particular what exactly you want to use, if you want to use with respect to adaptive or analog RF or a beamforming or a code generation, there are different, again, if you want to use different instruments, then these are the instruments that are available. Fine. I think someone has asked with respect to instrument part. So if you are going, these are the instruments that is currently available that can be used here. See here, the
Madam, can
VSSA,
you check the RF power meter in this?
RF power meter.
Or RF power meter or RF power sensor?
Sir, that part I need to check whether it's available or not. So these are currently, these are the currently available. Actually, mine is old version. I didn't download a new version. 1 second. So I'll check with respect to your, I think. Sir, what you requested for?
This, Madam, RF power meter, like a bolometer type.
No, sir. I don't think so. It is
Nano
available
waste.
here. No, sir. It is not waste, but
Earlier
you
it
have
was
to.
there, madam. Earlier it was
Ma'am,
there
can you
RF design
expand
in
the
that it maybe.
wireless channel? Can you expand wireless channel now? Yes. Previously it was there.
In the current library?
No, in communication, I guess. Channel types. What are the channels available? Communication is.
Ma'am, these
The
are the, I
communication
think,
comms channel, wireless channel model.
ma'am, I think if you installed, you can go through, I'll give some time so that you can go through, and if anything is you are looking for, if you're not able to find, then let me know, ma'am. So these are the different things are there that is available in different library files. So if you are aware of what exactly you're designing and what all exactly needed, that you have to select with the library files. And these are the things that are available, you can go for it. Anything, it is not only communication, we have like a different adaptive equalizer, RF and along beam forming. If you, for example, if you go for beam forming, we have transmit array, S parameter, we can do modeling of the S parameter, envelope matrix delay. There are multiple things are there, ma'am. I just give some time. You people, means all of you can go through the part selector so that you'll familiar with respect to particular things. If I go automotive radar, again, there are different things are there with respect to only automotive part. So we can use all those things. So even for with respect to RF design, again, we have different RF design parts here. For example, you can already existing attenuator is there. Bandpass filters are there. Different filters are there. And coaxial cables are there. If you know which coaxial cable you want to use for your design, then that can be used, right? And even we have a divider. We have different switches. Even we have different ports, detectors we even have a limiters. Many things are there. I request all of you, please go through this part selector. I request all of you, please go through one part selector so that you are familiar, will be familiar. Fine. So when you generally open, this screen will be available, visible. That is, this is one basic that is meant for your design, nothing but a schematic. That is workspace, schematic design. This is workspace where you are going to see your design name, graphs, table, and you can write all the things. Okay. And where you can open new or the create new or open new, fine. And these are different helps are there, fine. So this is the basically, all this file, edit, view, schematic. These all the tools are there available here. And this, all the basic things are here. This is a green triangle is for run the analysis. What you are going to design that schematic, that is for run. Okay. So we can either run all or run with respect to a particular design. Okay. And this is for meant for, this is for if you want to tune your design, then or tune your any of the things or the frequency, then you can use a slider here. Fine. Then you just place your slider. It will show the slider. You can drag and drop. See here, you can show the slider and you can change. Fine. Currently, I'm not using anything here, so I will not use this slider. Fine. And this is if this part selector is, your part selector is not available. Fine, it is not visible in this. Then either you can select from here, or you just press on this, or you go for view, and you can activate. You can activate part selector, or if you want to see simulation log window, then you can view, click on this, you can select that, or whatever you want to use, no, even if you want to use command prompt or the compilation log, you can select and it will be visible on this screen. Suppose I said command prompts here, this command prompt is visible here, right? So I don't want it, so I didn't use here. I just closed this. Whoever is want to use this, they can use. Okay, all the things. Fine. In the schematic, we can create a new schematic, right? Or you can add your title block, or if you want to place your schematic properly or fit in the proper page like this. I'm just dragging and dropping and making the window small or big, no? Instead of that, you can use a fit page or reapply auto designator, all the things that you can just go through once, all these things. Okay. This is action to run the simulation. Fine. And this is a tool where you can see here with respect to library. Fine. You can see with respect to license, that tool can be seen here. See, it is also supported. Golden Gate simulation setup we can support here. This system it supports. This is all. And this is help. If you, for example, if you want to do, if something is not like, if you're not able to do anything, you can take a help, and then you can search a particular information. If you know the particular word or the thing, then you can search. You can go topics and windows, or you can go for example or the tutorials, right? If nothing is available, then you can go for the eSite support or the care. Okay, so anyone will respond for sure. Right? I hope if you are familiar, means if you got this system view, like if you have seen both, if you've gone through this system view window, can I continue further? I'll just give one example, I mean, to make you familiar, so that
Madam, I
can
want to know how many features it has any similarity between ADS or like a normal system view, or it has some more advanced features, madam?
Compared to what, sir?
ADS.
Sir, ADS is basically a circuit design. In ADS, we can do, or only to some extent, we can do system design, not to the entire extent. But in system view,
okay, madam.
In system view, sir, if you design a circuit, also, I mean, sorry, in system view, you can call a circuit what you have designed in ADS, you can use in system view. And you can completely design at system level design, higher end system level design you can do. That is, I'll show one example, sir. I'll show while doing some session, sir. We can do completely entire system level design. Even if you design any antenna in ADS or EM Pro, that can be called in system view. That file can be used in system view. There is no problem, sir. Your design, your circuit design can be used in system view. If you design your amplifier also, that amplifier can be used. Instead of using your from the library, you can use you create your design circuit of amplifier can be called in system view. So that according to your system level design, you can proceed further. Shruti ma'am, shall I continue?
Madam,
yes,
madam,
sir, yes,
in
sir.
the system view software, this ADS is built in, or ADS is different from the system view, or system view is different software?
No, sir, it's a system, it's a different software, but we can, it supports ADS also, sir.
Okay.
It is, it is system level design, that is a circuit level design. So both are different, sir.
Yes, ma'am, you can continue till 1, ma'am.
Yeah, okay. Shall I? Yeah, I'll give some examples. I'll give one example, just a basic example, so that make you familiar. I'm doing nothing here, just to make you familiar. Whole installed, they can continue along with me. Okay. So create one blank, right? Either you can name. Actually, it is not showing name here. Anyway, let it be blank. Fine. So when you open a blank, design is there. Fine. If you want to design, I'll just give an example. I'll just, if you want to change name of the design, so you can name what exactly you are doing here. I'll just give an example. example. Example 1. I'll say example 1. See, it is changes to example 1. So this is a folder is already present in a blank. Fine. So I am changing example 1. Instead of a design, I'm changing the example 1. So in this, by default, in this blank, when you're going to click on the blank, by default, it is giving the design and the analysis part along with the equation. These three are already by default. Fine. So when you click on this design, if you want to rename your design, I'll just right click, rename. If you want to rename, just right click. See, if you right click, then see what all the things can be done here. You can add equation, you can write notes, you can add different parameters of scripting, or you can configure, right? You can rename. If you don't want, you can delete the design. You can go for the properties. If you go for the properties, what are all the things it is? It shows it is a design 1. If you can give description. If you want, you can change the symbol with the existing, like you can take from the existing library. Fine. See, these are all the things you can check. If you don't want this, what this symbol is there, I can use this or any of this. Okay. Currently, I'll say cancel. I'll let it be as it is. You can rename if you wish, or else let it be as it is. Fine. So when I double click on this, I'll get this schematic window. Fine. This already open. My schematic window is already open. So I will take an example of adding two signals. One is a sine signal and one is a noise signal. So let's add two signals so that you'll be familiar with that. Okay. So that how exactly can be done. Fine. So I'm just adding two signals. Nothing I'm doing here, just adding two signals and saying the in terms of spectrum and in terms of the normal plot. Okay. So to add two signals, what are the things we need? For example, if I want to add a sine signal, then I need sinusoidal signal, right? So where to select that sine signal, the sine module? So come for the part selector. Fine. Come for the part selector. Click on the current library. Say all algorithm. Say all. Or you can take general algorithm design. Fine. Now, when you take all, means our current library is algorithm design, then category will be all. If you want to take all, let it be all. If you don't know, then let it be all. If you know particular things, then you can take particular. Fine. I will in filter by I will search sine. I will search sine. See here, there are different. Resample RC, fine, sine generation, sine wave generation, fine. So I will take a general sine wave, sine signal, okay. Just click on this. This is sine signal, what I got. I'll make a zoom. See, this is your zoom screen. Click on the zoom, fine. When you click on the zoom, see here what all it is. It is showing this is one is outgoing. There is a one outgoing arrow mark with a blue color, fine. And here, what is the name of this symbol is? It is S1 sine generation using a data flow model. So we are using a data flow. We are not using RF flow model. So we are using data flow. It is showing data flow model using, that is we are going to generate a sine signal. Of amplitude what? Of amplitude 1, offset is frequency with respect to 5 kHz. Okay. So if you want to change amplitude or frequency, all the things, then you just double click on this. Double click on this symbol, sine symbol. Just double click and then you can change the name S1, can change the description also, or let it be as it is. If you want to change the model, if you want to data flow model, you can let it be data flow model. Fine. If it is data flow model is only all well, so you can use a data flow model. If different models are available, then you can select the different models. Okay. So currently data flow model, because we are in data flow. So it is showing data flow model. Okay. So now in this model, it is showing what is the amplitude, what is the offset, what is the frequency, what is the phase, and so here advanced parameter. If you want to, these are the things are available here. Fine. These are the by default, and units is given here. What are the units you want? You can change the unit in different terms. Okay. So here is default values. These are already given as a default value. Fine. If you don't want to use a default value, then uncheck and then change the value. If you want to use a default value, then check. Okay. If you don't want to use a default value, then check. uncheck it. Okay. So I'll keep as it is. I'll not do anything right now. Fine. Then if you want to tune, for example, I'll put a tune mark. If you want to tune your frequency, then you can go for the tuning this. Okay. If you want to show, if you want to see this particular parameter in the schematic, amplitude or offset, if I don't want to see, currently see here, if I don't want to see offset value, this word value, offset, I don't want to see offset, then you just uncheck this box. Fine. Uncheck and let it be as it is and show. See here. See what is the changes? Earlier was amplitude, offset and frequency. Fine. So what it is showing here? Offset is not there because I said I don't want to see offset. So it is offset is removed. Fine. Now here there is a green. In earlier was frequency was in a blue color, but now it is in a green color. Why? Why? Because I used a tuning. That is, I can change a frequency value according to my desired things. I can change. I don't want to go every time in the inside the sine module and to change. Instead of going every time in the module, I'll change here outside itself. Okay. So I can change how you go for annotation. Then you select this part, slider. Then you just place the slider. You can change here. See here. You can change this. You can change the slider. Oh my goodness, it is not working. Okay, I'll show this later. Fine. You can tune this frequency. Okay. So this is one sign I took. Fine. If you want, you can take another sign signal only with a phase shift of different. I'll take another sign symbol. Or if you, instead of going part selector, I can select here only. I'll just say copy and then paste. So I'll got here. Fine. So instead of again here, you just make a phase shift of 90 degree. So I'll just adding sine signal and the cosine signal. Okay. Then, so two signals I am taking, or you can take another signal also. You can take a Gaussian noise, means any other signal. See, if I got a Gaussian noise, I'll take this independent identity Gaussian noise. Fine. I'll take this Gaussian noise. Fine. And then I'll place. Are you people following me? You try to do along with me. Then only you'll come to know, you'll be familiar, or it's not possible. Okay. Then you take again, if you want, you can again double click on this. You can see what all the things are there. You can change the standard deviation value to 0.1, some value. It is not particular I'm doing here. Some value. Just say okay. Fine. Now I want to add all these three signals. Then you go for here again, filter design, filter by add. Just type add. So what do you want to add? Multiple input adder. See here, there multiple things are available here. I will show you here. Adder means there are multiple adders are there. Which one to select? That is again important for us, right? You want to add general, then you take add. Fine. With respect to envelope adder, we have. If you want to add multiple, that is matrix, then you have to use M. Last word should be M. Okay. Matrix. M represents M, matrix addition, matrix multiplication. Right. M always, wherever in whichever part you are going to select, if there is M, then it is representing matrix. Okay. So I will take general add over here. I'm not going to take matrix because I'm not doing any matrix multiplication addition here. Right. So I will take here. I'll take add, place on the schematic. I'll just write fit to. Okay. Then see here. In matrix multiplication, sorry. In addition, there are three terms, right? So I am adding three terms. So what is here? See here, there are red mark, two arrow symbols. These two arrow symbols indicates it can add multiple things. Multiple addition can be done. So multiple inputs can be taken here. So this, okay. Now to connect all these three to this, then you can use this wire. Click on this wire. Fine. or directly place a cursor on the arrow mark where will be visible. Either you, all of you getting? I hope all of you getting how to do connection. So just do connection like this, then add. That's it. I hope all of you got it. Now, if I want to see output, I want to see output result, right? I want to see output result of sine, cosine, and this Gaussian noise. Fine. Then I'll add sync. Sync is output. Okay. Sync is nothing but output. See here. If I say sync means we have got different things here. Digital model demodulation. This is a flex card sync, that is nothing but an instrument. This again there are two more instruments here. Okay. Signal vector signal analyzer. There are here. Okay. Of the case site. So I'll use a sync, data sync. Connect for data sync here. Place one click on the sync and remove. Take the cursor on the schematic. Just one click. Okay. Now after this, connect this sync. Address sync to the output. Fine. And one more thing. This is a general output I want to see. If I want to see spectrum in terms of a spectrum, then you just type here spectrum. Then press. See, only there is one spectrum analyzer that you can see. This is again. Fine. Again, you can connect here. From this point to this point. Fine. If you don't want to use this, click on this, press this. That's it. Disable. I don't want to use. That's it. If you want to use, then let it be. Okay. Clear? I hope all of you clear. This is the basic part. Now, once this is done, now go for the simulation. See here, I have to run the analysis. Fine, I can run the analysis. But before that, you go for here, example 1, come for the workspace, come on the example 1, right? Here, add, come here, right click, add, come down. You can select what analysis you want to do. There are 4 types analysis. That is 4 type analysis we have. One is a data flow, because I'm designing data flow module here. So it is a data flow analysis. And another is a phased array analysis, RF system analysis, and system C analysis. Right? So currently I am using a data flow analysis. So I'll use a data flow analysis. Fine. I will not use anything. And a phased array analysis, system array. These are the different analysis. Currently I have data flow analysis. Fine. So I am using data flow design. I'm using data analysis. It's already present over here, so I'm not going to add another analysis. It's already present, see. It's already present, so I'm not going to add. So when it is not there, when you're going to create a new folder, then you can add different analysis according to your module. Fine. Now it's already there. Then I'll see here. Currently there is, if I double click on design 1 analysis, no data is available. Fine. You can take any, you can set up your start and stop time, sampling rate, or anything, whatever it is. Okay. Power of 2 or whatever it is. I'll just say, okay. Fine. I can say here calculate now. Here also I can do, or directly I can do run analysis. Fine. I'll show what will be happen if I do run analysis over here. So I run the analysis. See, I did not get any error. So my here the data earlier the data was not available, right? Now the data is available. So design analysis 1, the data was not available in the earlier one. Once it is run, it give another design 1 analysis data. Means which is data is available now to see your result. Fine. You can click on this design 1 analysis design. Fine. You can do even calculate. If you change any modification, you can do or calculate now itself. Fine. Now where the data is available, right? There is a graph, this green graph. So click on this, double click on it. You should get another pop-up window showing that what all it has, your output result, right? S3. So it is showing in terms of time graph as well as the normal points, time value points. Fine. And these are the different things are available. You can check. Okay. If you just a second. Just a second. Hello. Yeah. See this. Now see here. What are the things? This can be done here. You can see it different with respect to time, with respect to phase. You can see the in terms of power. All the things can be already visible. Fine. If you want to plot particular graph, I want to plot S3. Then right, keep the cursor on S3. Right click, add new variable or add table or add graph. I will go for add graph. Simple. See, I'm getting. Now, what is exactly S3? Right? What is exactly S3? If you want to see what is exactly S3, then I have to go for my schematic. What is exactly the S3? Because see, where is my exactly S3? See, S3 is nothing but a output of the normal signal graph. If I want to see S4, S4 is my spectrum analyzer, right? I can see here. Either I can see here or I can see here at the design. Fine. Once I click on this particular things, particular sync or the where the data is available there, then it will give one more graph, that is design 1 analysis of design S3. So it is giving S3 output. So this is output. If I don't want to go here and plot a graph, then in the schematic itself, I can plot graph at particular module. That is, see, keep on the cursor 1, 2, 3, right click. Sorry. Oh, sorry. Not here. I'll show this later. Come for here, design schematic, click on this, add graph, example one, right click, add graph. In that graph, what all the types you want to display? You want to display cancellation diagram or eye diagram or histogram. We can plot different types of graph. I want to see one is a normal graph and one is a spectrum graph. So if I want to plot a spectrum graph, what is available with us? So what is a spectrum? So I want to draw spectrum of S4, this part, right? This is S4. So I will just plot S4 and then say, if you want to change anything in this S4, then you can go for edit equation. You can change your, see here, S power. You can change here the value. Fine. Using design analysis of design data, it is showing design what you have designed, that name, and it is S power 4. You can change your this value here. Okay. I'll just cancel and then say okay. Color is red. You can select any color. I'll select some other color. Any color. I'll say okay. See, this is a spectrum graph. Okay. Some spectrum graph we are getting. We didn't design any particular proper thing, right? So we are not. Similarly, if again you want to add, or else if you want to add in the same graph, see here where it is in the same. So adding 2 signals, I am getting some signal. Adding 3 signals, I got some signal here. See, adding some 3 signals with a noise, I got 2 signals with a noise, I got the signal. This is all corrupted signal with noise. Okay, you can see the particular value at particular placing cursor on the particular point. It will display all the values. You can, the way you are going to change, that way you're going to display. Okay, so this is how you are going to do. Fine. Now I'll change it once again. one more thing I'll show you in this part. If you want to see adding, we got a proper output, right? We added two signal, we got something. Now, if you want to see this signal at this particular input and this particular input, there you can connect one more over here. Take a sync. I'll just show sync and you can connect. Sync is meant for seeing the graph. This output. Okay, play sync and then you can just directly connect to this. And you can see here. Then just go for run analysis and it will show. When you're going to go again, it will show one more thing. Again, you just either you can run here or you can run here. Okay. I hope all of you got familiar with system view, so that in the afternoon I can go with how to generate bits, how to check bit error rate, how to analyze error vector magnitude, cross correlation, right? If you have any kind of equation with you people, you let me know so that I can, or theoretical design. Yes, sir.
Madam, can we do the modulate the signal?
Yes, sir, we can do modulating signal. I'll show, sir. I'll show
And
this example.
in place of like adder, if we connect some other device to see the output of that after, like
So
suppose you have connected, madam, here adder. Na, in place of adder, if I am connecting any source and I want to see the modulated my output, then is that possible?
Yeah, sir. We can see all the things. I'll show one example. This is just a normal basic, some examples I have shown. This is best to make you familiar. I'll show how exactly the QPSK, that's modulation, can be done, or how we can do all the things. I'll show you, sir, in the afternoon. We can do, sir.
Okay. Madam, is that available in this library? This any like a this RF source like a LED or any like other source here like a to see the modulated signal of LED or like any other thing? Any source like a RF?
Sir, you do one thing, sir. If you are like so much, you just here type your source. You can see if go for instead of all, you just go for here all, sir. This is all. Go for all category. You will see different types of. So you remove all this here. You will see check what exactly it's available. I cannot say that whether LED is available or not, but you need to check all the things what exactly you want so that you can place that particular part.
Or if LED is not available, can we design here that in place of this adder?
So you can design in ADS and then that can be called here. No worry. ADS circuit is in ADS circuit design we can do. That circuit can be called over here. You can do that part.
Thank you, madam.
See, it's a binary random bit is available. If we can different types of
Hello,
bits can
madam.
be generated.
Gayetri, madam, once again. So,
Yes, sir.
in the category, you just select, you just click on the category. Below the algorithm, you find one category, you just click on that. So, in that, you can see instrumentation part. So, in the instrumentation part, you will find all the instrument key site available instruments.
Yes,
so,
I
in the
said
post,
the same.
yes. And in the co-simulation, you will find that ADS to system view link, the co-simulation is also available. So I think I see one question in the chat box. That's why I interrupted.
Okay. Yeah, so this is the co-simulation.
You just tell about the thing. Yeah, yes. You just tell about this thing. ADS import to system view. Yeah, how we do that.
Yeah. So what are the whatever you're going to design in ADS, no, that can be called in system view with the help of this co-simulation things. If time permits, I'll show how exactly the co-simulation can be done if time permits, right? Or else like some other, whenever you get any like any, if it is time is not available, then can make a separate call. I'll explain how exactly to do this. Shruti ma'am? Ma'am, we can ask all the participants, are they familiar with like system usage right now? So that I can go in the in the afternoon session, I can go with the design what exactly we scheduled.
Okay. Says participants, can anyone reply? Is that fine?
Yes, ma'am.
introduction for this system?
Yeah, it's fine. But
Yes, madam, it is fine.
we
Go ahead.
have a little problem in installing that software. Probably after this session, if somebody helps us to.
Yes, ma'am. Vidhya ma'am, I will just call you.
Yeah, sure.
And I help you throughout that.
Sure, thank you.
Okay. Yes, ma'am. Gayetri ma'am.
Yeah, ma'am. Shall I continue?
Okay. It is 1 o'clock now. So can we have the break?
Yeah, sure, ma'am. Sure. I'll come by
2. So
yeah,
we should
sure, ma'am.
start at 2. We'll come back
Yeah,
at
ma'am.
2.
Yeah, sure, ma'am. We'll come back by 2 o'clock.
Hello.
Yeah, yeah. Hello, ma'am.
Yes, ma'am. All the participants can take a break for lunch and we'll continue the session at 2 p.m. Is that fine, ma'am? Gayatri ma'am and Muthukumar sir?
Yeah, sir. Yeah, ma'am. It is fine for us.
Yeah, yes, it's fine.
Yes, ma'am. So all the participants can take a break for lunch and we'll join the session at 2 p.m. with the same link ID.
Okay, ma'am.
Yeah, thank you.
Okay, ma'am. Bye, ma'am.